Welcome back to the stream, everyone. Happy Friday for those of you tuning in live. We've actually got this live cat that matches kind of closely with the slide that I had there. He's in a good mood. He's got a keyboard to sit on. He even knows that it's plugged in. I think he knows the keyboard's actually connected to a computer, which makes him happier. He knows that he can kernel panic it at any time. Ken waves from chat. Hi, Ken. Nice to see you again. I thought I would start this stream off with something a little unusual for me, but something that a lot of people seem to enjoy, which is mailbag segment. I got a lot of stuff in the mail, and I think at least a few of these things are actually relevant to what we're talking about, so I thought I'd start with that. So, let's see here. I missed one slight preparatory step. I had meant to block out the addresses on these packages, but I forgot that. Meanwhile, you can enjoy Tuco, and I might explain what else we're doing on the stream. So I was going to work on this project, which incidentally is actually completely cat related. So as you can tell, I have this adorable fur ball that I usually like having a camera pointed at. And so it's left me with the intense desire to build a robot to help out with that task. So that's what we'll be working on. Basically, the robot has two components. There's basically a moving platform with a camera on it, and then there are 4 of these little things that I've been calling winch bots that are just oh no, Tuco's climbing onto the package stack that I'm actually still trying to fuss with. Hey Tuco, maybe you shouldn't do that just yet. And so the winch bots are basically just spools of paracord with motors and some sensors on them. So in addition to actually being able to spool up the cord to, pull the cord through a pulley, and then I guess we don't need that anymore. So yeah, so basically, it's going to have a movable part that's as light as possible, and then some little sensor-equipped single-axis CNC machines, basically, for moving that around. Oh man, Tuco knows that there are boxes here. Hey Tuco, there's one more for me to put a sticker on. Oh, little dude. Alright, let's get another camera angle. So yeah, I think are going pretty well. On the movable robot front, there's basically, basically I have a camera picked out. I want to stick it on a 3-axis gimbal so that I can both aim and stabilize the camera. And then it'll also need, a little bit of additional electronic-y goodness, so probably an SDI video amplifier and a Raspberry Pi, and maybe a little servo controller board. So not a lot, but, a few circuit boards at least. And then on the ground side, basically we can have as much there as I want, but I've been trying to keep this project relatively simple and cheap. So I picked out these motors, basically looking for the thing that seemed like it would work, that was cheap and widely available. And so there are these little kind of ubiquitous worm gear drive motors that you can find on eBay and similar places. And you can get them in a bunch of different gear reduction ratios, but they all have basically the same power motor in here. And it's not the most powerful motor, but I don't necessarily want these robots to be super burly, both for, you know, I don't necessarily want this thing to be capable of hurting anyone, and I don't necessarily need it to be moving around something really heavy or really fast. So, you know, ideally this thing would kind of just calmly move around in the sky and track the cat from a relatively safe distance without having to, you know, without having to have a lot of power behind it, because, you know, that also is not something I want, just like running a lot. You know, I want something that's relatively calm, that won't scare the cat, that won't scare me, that won't break frequently. But that has left me with, you know, I think I've got a plan that's going to work out for the camera portion of this, but I am a little less confident that I've got a powerful enough motor. So I've been doing some CAD design, and I've actually got one of the parts printed already. So this is half of a spool. There's another piece that I'm printing right now. The paracord goes through this hole to anchor it. There's an access hole for the set screw that attaches this to the motor shaft. There's the kind of D-shaped motor shaft, and then a place for me to put in a captive nut for the set screw. So, you know, when I was designing this, I was probably way too worried about making all the plastic parts strong enough, because I'm like, oh man, this thing is like holding up a robot. I've got 3D printed plastic parts holding up a robot. That's terrible. But then it turns out that actually the really big limiting factor is probably going to be the motor's stall torque. Because even though it's a worm drive motor and it's not going to just, you know, spool out when the motor is overdriven, which is why I'm choosing a worm gear motor, you know, it's not going to be able to pull at all if it stalls out. So I think I'm probably going to be all right, because for most of this, so, you know, part of the design challenge here is that the effective diameter of the spool changes depending on how full it is. And, you know, so when the robot is close to the ground, you know, I'm not going to have much cord on here, so I'll actually have a lot of effective, oh, hey Tuco. Oh, he likes this stuff. Yeah. Well, so I don't think the cord's going to be quite at like cat grabbing level, but I guess this is a concern for having a robot moving around on wires. But yeah, another good reason for not having a robot that's strong enough to hurt anyone. So anyway, so one thing I hope to do once I've got that other part printed is to actually do some practical tests. When I designed the spool, I was thinking about the diameter most in terms of making sure that it would hold enough of the cord. So, you know, basically sizing it to fit a room even bigger than the one I'm in right now for a little bit of, you know, design flexibility, and then calculating how much cord that's going to take and how much spool space that takes, and, you know, all that, and then basically figuring out the range of the minimum and the maximum diameter that I have to work with. And so I was thinking about that in terms of speed, but not necessarily in terms of torque. And so I was noticing that just attaching the motor to a wheel this diameter, it gets fairly easy to stop with my hands out at here, which doesn't seem like a good sign, but we'll see. I'll do a test once the other part finishes printing. In the meantime, I thought we could focus on the gimbal, because I think I've got a pretty surefire plan for the gimbal. We've got a gimbal that's designed for a GoPro, and you want to keep playing with this, Tuco? He kind of likes paracord. I've made paracord toys for him before. You know, I don't let him have small strings, of course, because those are really dangerous for cats. But this stuff, you know, he's not going to eat it. He's just going to, like, try to kill it. He really likes the texture of it in his teeth. So it's something we can play with under supervision. Hey, too, is that stuck on your claws? Oh, yeah. So, let's see. Let's open some of these packages, maybe. So, this one is from China. Where in China? Dongguanqi? I don't know where that is, but it's labeled plastic toy accessories. I think this is a really cheap gimbal that I got as something I was going to try for this experiment until I found the, you know, the kind of mid-range gimbal that I'm using right now. But this gimbal, I think, might actually just be, how do you even open these? I don't know. This gimbal might be something I can use for like a bolt launcher or a laser pointer or something, depending on how bad it is. We'll see. It's, I think if this is the one I'm thinking about, it's only 2-axis. Oh yeah, I think that's it. So this is definitely related to the stream. This is a slightly even less fancy. I mean, so just to like put these in perspective, the gimbal that I've already mostly disassembled that I have that I'm planning on using for this project, that one is, you know, it's also made by you know, a company in China that I ordered like from eBay. Or no, I guess this one was from Amazon. But either way, you know, that one seems to be made pretty well. Like it was like one of their lowest end gimbals, but it was like $170, which, you know, seemed like a lot for this project. But, you know, I looked at the range and I knew that I wanted a 3-axis gimbal, and to get one that didn't suck, that seemed like about the minimum. But this one, I wanted to, like, this one was just so absurdly cheap that I was just curious to see what was even going on, because I've seen some really cheap gimbals that are based on like DC motors, and that just seems like why even bother? But this says it's brushless, and this one was like $50 or like maybe even less, like $45. And this one's also designed for similar GoPro cameras and for use in quadcopters. So yeah, and they've got some instructions for like tuning the control loop using a Java GUI here. It's interesting. I can take a closer look at this on the other camera maybe. I just don't want to turn away from the cat on this camera because he's so amazingly cute right now. I can take a closer look at stuff as it warrants after we actually open stuff. They threw in a servo because I guess I ordered a gimbal that was slightly, like $4 more expensive than the gimbal they actually had in stock, and so to compensate for the value difference, they sent me a micro servo, which was a little weird, but all right, I'm not complaining. This looks better than I expected, actually. So it's in this like weird foam box, and it seems to be all metal and brushless, and it looks similar actually to the one that we've already taken apart, just maybe not quite as nice. Because like I can already tell that the metal is like rough around the edges and maybe not machined or plated especially well. So they've got some connectors which we can hold on to. How do they intend you to open this part? This is like glued shut, and it doesn't feel like this actually will fit through the opening that they've left. Okay, it does. It's just, huh. Wow, this is actually not bad. So all the wiring is on the outside, which is, you know, good and bad. It smells terrible. I can't tell if that's the packing material or these rubber gaskets here, but something on here is outgassing. Yeah, the wiring is kind of chintzy. Actually, what is this? I think some of this might be silicone, actually. There's some printing on it. Well, we can take a closer look at this under the camera. Yeah, under the microscope, because I don't want to get my face close to this thing. It stinks. The motors look fine. They're definitely brushless motors. You know, pretty wide seated kind of pancake style. So this is not bad. This definitely might be up to pointing, you know, some kind of little bolt thrower kind of thing around, maybe. So yeah. Yeah, I mean, I'm probably going to get rid of these grommets anyway, because I don't need that. In fact, can I just take this whole part off? Because if I'm not mounting this on a quadcopter or something else with insane vibration like that, this part is not really necessary. Like, you can tell that all the handheld gimbals don't include those. that's not all of the stinky rubber, but that's the majority of it. But yeah, actually this is not bad. And this down here is definitely like an I2C inertial sensor of some sort. Yeah, this one just kind of holds it all out there. Everything is very exposed. And you can also tell that they don't have multiple microcontrollers like the other one, because they're just not really worried about having all this wiring. There's a lot more wiring going on here. Oh, the circuit board's interesting. We'll take a look at the circuit board once we get to the desk. Let me file the pieces I want from this in a nicer box and throw away the stinky stuff. Well, when I say nicer box, it's a 3D printed temporary box, but it's nicer than stuff that's gross and chemical smelling. Okay, so that'll go with the gimbals. Did I already lose the instructions? Do I even care? I probably have the instructions somewhere. I'll keep the other aluminum plate, because aluminum plates are handy. Oh, I put the instructions with the other stuff. That's how smart of me, accidentally being conscientious with the paperwork. Okay, this is going in the trash. Okay, well, Tico seems to... Oh, he's going back for more of his dinner. Yeah, I made him something a little special, and he only ate a little bit of it, but now he's eating some more. This is something else that I think I ordered from eBay, but it was shipped from San Francisco. Let's see what this was. There is bubble wrap. It's kind of heavy. Oh, load cells. These are also for WinchBot. So this is part of my plan for feedback. Oh, these are load cell amplifiers. I think this is one that... I think this is like a Chinese breakout board for... I think it has a model number like HX311. It's basically an all-in-one load cell amplifier that, you know, measures various tiny changes in resistance, which is how these work. And then it gives you just an I2C interface. And I had some load cells that I had taken out of like digital like body weight scales, but those were just way too burly for this humble little WinchBot. Since my little WinchBot needs to move this little thing around, this little camera, and the motors themselves, you know, as I mentioned, don't have much stall torque. So I needed a load cell smaller than the ones that I had, which I think were rated to like 50 kilograms. So this one is rated to top out at 5 kilograms, which I think is closer to what we're going to be dealing with for each one of the 4 WinchBots. So I already modeled this based on some kind of guesstimates of which CAD drawing actually matches this part. And this actually looks like what I've been seeing in CAD for the last few days. I didn't know if these holes went all the way through, so now I know they do, which is handy. But yeah, basically this is a piece of metal that is, you know, drilled to be strong in every dimension except in one specific way. So, you know, it resists kind of torsion this direction and kind of bending this way. But if you bend it the way that the arrow tells you to, which is like kind of how I'm mocking with my fingers, then there are these 2 very tiny resistors that I'm pointing to with these 2 fingers here. This is maybe a little easier to do under the desk later, but yeah, anyway, there are two resistors that stretch very slightly as this metal bends, and that amplifier can measure the difference. So I've got a design already kind of partially put together where my plan is to have one side of this load cell static and then the other side attached to a pulley, where I have taken care to make sure that the angles of the force on that pulley kind of stay constant as the winch winds and unwinds to differing degrees. So that's part of what my design is concerned with, is that I want to make sure that my measurements of the forces can stay constant even as all the geometries involved with the kind of chord angles and the winch angle or the winch fill levels change. So these will be handy. Let's keep the drivers and the load cells together. Knee cam. All right. Put it away later. What else? Here's another one that looks like a random eBay package. This one seems to have also come from California. Oh geez, Ken in chat is starting to take bets now on when I move away from these little cheapo gear motors to like brushless motors for the winchbot. I was thinking about brushless motors. I mean, the problem with that is that I have to do the gear train all myself, which is more trouble than I was hoping to go through for this, but yeah, it's certainly doable. I just can't do direct drive really because they need to be able to hold their position without power. So it looks like we've got a bunch of little things. Small objects. Somebody could probably Google this model number and tell me what they are before I even open these. But that would spoil the fun, so. Felt like there was something in there, but it was just the shipping label. There are 5 of these objects that seem to be the same. That seems like a quantity of something that I would order for the winchbots. 1 for each winchbot, and then a backup so that when I make a mistake, I have a spare. So these. Oh, motor drivers, yep. These are just pretty run-of-the-mill. Like, you see these in a lot of hobby robot projects. I forget the model number. It's like an L293 or something like that. That's probably not right, but I mean, people who have these will probably know what I'm talking about. Yeah, do any of these actually have the model number? Can I just read the chip, or is it too heat-synced up? L298, yeah. It's a motor driver by ST Micro. And so this just has a big old heatsink and some capacitors, so that seems handy. This will handle a much burlier motor than the ones I currently have if I continue to go with DC motors. Otherwise, you know, brushless, but then I need the gear train. So this is a lot of packing though. Maybe I should unwrap some of these, but I can do that later. These will find a home somewhere else for the moment. Oh, there's Tuco. Oh man, how am I going to do this with Tuco hanging out over here? Hey Tuco, you want to join the mailbog? Would you like to swim in the mailbog, fellow cat? I think that's a no. Alright, well, I'll just stuff these in the slightly disorganized box right over here with the other project components. Next. Alright, we have 2 DigiKey boxes. And why do I have 2 DigiKey boxes? I think I thought that I had a way of getting cheaper shipping by ordering one of these first class and one of these priority mail. But then they like arrived at the same time. That probably worked out all right. I don't know. I probably could have just shipped them all. I think I ordered this one first before I had actually decided on this. Which I'm already giving away that I know what's in these based on the size. But this one is a much bigger box than I think it needs. Oh man, this is going to attract the cat, right? Cats always like this stuff. Oh jeez. Wow, yeah, this is some good stuff. We'll definitely need to look closer at this. This is some coaxial cable. It is some very tiny coax. Oh wow, this is Yeah, so I forget what the diameter of this is, but this is basically the smallest coax that I could find. And I think it might even be overkill for this project, but we could take a look at it. It is 42 gauge, and this is just a 10-foot length of it on a spool. Yeah, apparently you can get just like a little bit of this from DigiKey, which is nice. Am I going to entice Tuco with any of this? Hey, Tuke. Oh man, he's having a good time looking out the window, but he does seem interested in this stuff. So, I'm not gonna leave that now. I'll put that nearby in case he gets interested. All right, this one is from Amazon. I don't know what this is. I think there's a small thing related to this project that I got from Amazon, but I don't know why, again, it would be such a large box. Oh yeah, this isn't actually related to this project, and it shouldn't be such a large box. It's everyone's favorite USB to serial adapters. So actually, these aren't even the ones that most people want nowadays, which are the TTL adapters. I just actually needed some more of these because I realized that the only working one that I had left in my shop, I took apart to make that VFD, pull display thing. That green thing that's glowing, I took apart basically one of these and built it into there, and then discovered that the one other one that I had in my shop was just broken, and it was potted, so there wasn't even really a use to find out why it was broken. So anyway, that's not very interesting, but it's a thing. So one more thing. Oh, that's an interesting suggestion. Kenneth in chat mentions that that if I wanted to go brushless, I could probably have another mechanism that that locks the cord, kind of like a mechanism in an elevator, I imagine, and that you could design it so that if I could imagine an electromagnetic thing, like a clutch or a solenoid that has to hold it open, and if it fails for any reason, like it loses power or the microcontroller crashes, then something just kind of pinches the paracord and keeps it from moving. So this one's a lot of packing material, but hey, Tuke, are you into this? Hey, Tuke. You're giving me a weird look, honey. You know what these are, Tuke? So I don't know if I've actually opened any of these on camera, but I've been messing with these on the stream already quite a bit. So this is actually the same dev board that I've been using for the voltage glitching and the underclocked Ethernet experiments that I've been doing with Senrio. But it also happens to be, as far as I can tell, the least expensive way to get a dev board that can do, basic motor driver and quadrature counting and that kind of stuff, and has Ethernet. I was thinking of, I looked at other options. ESP8266s are cheap, of course, but I don't want to rely on Wi-Fi for my motor drivers. I want this either on a dedicated Ethernet network or on something like RS485 or CAN bus. So I was looking at the options, and of course you can build something custom that includes RS485 transceivers and CAN bus transceivers that is relatively cheap. But I wanted to, if possible, make the WinchBot something that didn't really require a lot of custom stuff, that I could just design out with off-the-shelf parts and make that easy for people to replicate. And then, so then I was thinking about this thing, and this is cheaper than, an Arduino plus any kind of networking shield, and, It's got a built-in debugging interface, so you don't need a separate adapter. So anyway, they advertise this as the Tiva C series, but the actual name of the chip is the TM4C1294. And actually, the 4, I think, is the memory size. You also see it as the 129X series. So if I open one of these, you might have seen one of the, they might look familiar if you've seen the other. Do these not have a little cut for making it easy to open? Maybe they don't. But yeah, DigiKey has these for $20 each. They're actually a little more if you try to order them from somewhere that resells, but so yeah, that might look familiar from the glitching experiment, but this this has no wires or epoxy on it yet. So basically, it would need this plus that L39 I've already forgotten motor driver that I also just got in the mail, and and the that HX, I'm also forgetting, like HX311, I think, load cell amplifier. So basically, it's the kind of stuff where the breakouts are already so cheap and widely available that I think it actually even just makes more sense to, either just get some breakouts and show people how to wire them up, or even just have a really simple printed circuit board that just acts as a backplane to stack stuff together. So I think this will be actually a really straightforward project electrically. So yeah, sensors, it has the load cell, which will be I2C. Then it has a mechanical or an optical encoder. And it's one of the kind of nicer optical encoders that's in the sealed unit with the bearings. And that's because I already basically need something that is relatively strong and has bearings to hold the pulley anyway. And I thought about just putting magnets or an optical disc of some sort on the pulley myself. But to get a lot of counts of resolution per turn, I figured it was actually worth just getting like $12 optical encoders off of eBay, so that's what I did, but they haven't come in yet. But those should just attach to digital inputs, and I can probably use some peripheral on this chip to handle the quadrature decoding, or at the very worst use interrupt on change and do it in software. And this having the network built in, I would just have a separate Ethernet switch that all of the motor drivers connect to, and then the Ethernet cable that goes up to the camera or wherever the Raspberry Pi ends up living would have access both to the motor drive network and to whatever regular network I want to control it over. So I think that's enough yapping about this. Let's put this back in some kind of anti-static contraption. So I think I got 6 of these, which is why the box is so big. Which I need 4 of these for the Winchbot, but I just also like these boards, so I wanted to have a couple of spares around in the shop, because I currently don't have any of these that aren't involved in the voltage glitching experiments. This is just even more padding material. Man, DigiKey is giving me a lot of cat toys this time. I need to consolidate some of this. Tuco takes a liking to any of this, or if it's like all too messy, too old for him. He's just not into this anymore. He's moved on. Oh, actually, I need to refill my water, and Tuco is in the kitchen, so maybe I'll visit him and do that. Well, some ants that found some of Tuco's leftovers. It seems unfortunate. That camera is missing a vital SD card. Oh man, I have not tested my SD card emulator to see if it works in this camera yet. I'm actually really curious now. I'm sure the camera uses 4-bit SD mode, but it might use commands that the emulator doesn't support. Alright. Now I have no idea where Tuco's going to hang out. He's way over there. Okay. Oh man, the mess on my desk is different, but still such a mess. Wow. See that like bright red spot on the camera? Maybe you don't, but let me try to point to it. See that? That does not look like that in real life, but that's actually the image sensor on the camera I'm using. And it's like very reflective at just that particular angle. That's pretty neat. Or rather, you know, like that must be pointing directly at the lamp, and it just has this weird color due to the anti-reflective coating they're using. Anyway, we have maybe a few things to look at, but you know, insofar as focusing is necessary, I think my first actual plan was to try to make a cable using some of the coax that, well, to kind of look at the coax options, and then to see, like, you know, how well does it fit in the space available, and then if we kind of simulate the situation by just taking some arbitrary long length of it, terminating it, putting it in the circuit, does it work? If that works, then I think I'm comfortable with just starting to drill holes and stuff and actually like permanently modify the camera and the gimbal to make this happen. All right, so what do we got? So I have a few different examples here. I ordered a couple of different things because, well, so I didn't find this like fancy stuff at DigiKey until somewhat late, but I mean, basically, there's a lot of options in coax if you're dealing with 50 ohms, and this is not a 50 ohm system, it's a 75 ohm system, since that's the tradition for video for, I think, legacy reasons about power efficiency or something. But it's much harder to find coax that is small and 75 ohm, but it looks like with the situation I'm in, you know, which is a small length of cable with a reclocking amplifier right after it, that I can get away with a somewhat impedance mismatched cable as long as the cable itself has pretty good controlled impedance. So mostly I just need something that is a nice, you know, close to 50 or close to 75 ohm coax that I can snake into the tiny space available. So this is what we're dealing with. We need to be servo AF. So, okay, so let's take a look at these two gimbals, actually. So this one might be actually instructive to first look at this gimbal that just came in the mail, because it's actually really simple and, you know, contains all the parts that we're going to see in the other gimbal, but all just, you know, much more exposed and potentially easier to hack on. Ah, man, I can't believe this thing is... I mean, I guess there's not much to it. It's got some machining, it's got 2 brushless motors, and this one control board, which has nothing expensive on it. Alright, so we'll take a look at that circuit board under the microscope, but you can see it's one circuit board. I haven't checked whether this is USB for reals or another like serial port monstrosity. I think it's really USB, actually, because that's going to a Scilab CP2102 chip, which is a USB adapter, or USB serial adapter. And then this is actually an AVR. That's an Atmega 328. So it's got that. It's got a bog standard AMS 1117 regulator, and then a bunch of MOSFETs, which, you can see that they're driving 2 motors. Each one has 3 phases. These are probably dual MOSFET or like H-bridge packages. They're labeled U, so I don't. We'll take a look later maybe, but and then I think these are the servo inputs. But yeah, super simple, and probably designed to kind of flash your own firmware on and hack around with it. So this might be a nice thing to play with. But yeah, it's interesting. I wonder how well it works out having the motor drivers way over there going over this very tiny cable. So then the rest of this is all pretty passive. We have these motors. One big difference between these 2 gimbals, this doesn't have any feedback on the individual joints. So this is, I assume, running the motors pretty much open loop and just kind of guessing where they are based on the position of this sensor, and I don't see another inertial sensor on this board, so I think they're just guessing the orientation that this is in. So yeah, that seems maybe a little harder to get right. Whereas the other gimbal, each axis has its own magnetic encoder, which seems pretty nice. So here in the wiring harness, we have 2 motors, each one 3 wires. Then we have this 4-wire thing for power, and I think I2C for the inertial sensor. So that's the super cheapy gimbal. And then this one that we're modifying, same basic principle. You can see it's a lot smaller to start with. Each joint is basically just a repetition of the same pattern. So inside these wider sections, there's a driver board. Hello there, focus. So we took a closer look at this on the last stream. Well, the last stream of this project. And so this chip here is a magnetic encoder. So there's actually a magnet on the other side of like the axle. So this is just sensing that magnetic field rotating, and that's how it gets its kind of most immediate feedback for the control loop. And then right on top of this, the motor just stacks on. So these 3 transistors and 3 more on the back side of the board drive this brushless motor that just plugs right in there. So all of that is nice and local. They're not trying to drive the brushless motor over crazy long wires. And then on the back side of each of these, there's a little microcontroller, an STM32, and a buck converter. So each one gets its local 5-volt supply from this converter, local 3.3-volt supply, and then they all pass 12 volts down to feed those converters and to feed the motor drivers. And then this chip is an op-amp. I haven't checked to see what it's doing, but my guess is that the op-amp is probably for something related to motor feedback, but it could be related to the magnetic sensor if it's analog output. I haven't checked, so it could be either of those. And so each of these joints is pretty much the same. This one, you can see I haven't taken it apart, but this is the circuit board, then the motor plugs in, then this is the motor section. So the windings for the motor are actually just attached to this printed circuit board with headers, so it's a really clever design. One thing I'm not super impressed with, but does seem to be kind of the standard way these are built, is that all the wiring is just passed through these just holes bored through the motors and everything else. So that's part of why this has the microcontrollers in each joint. They have a really limited amount of space for wiring, so even if they wanted to have a single microcontroller that managed everything remotely and then drives the motors through a bunch of wires, that, with the encoders and, the motor, 3 phases for 3 axes, that would quickly become way more wiring than they would mechanically want to deal with. It would just be too bulky and too heavy for the joints to carry. So it seems to be a pretty nice design. I mapped out these, so they use basically the same pinout for all the connectors, ranging from all the joints up through the top, where there's another breakout that converts this to something kind of more standard. And so you can see there's power running down the middle. There's like a 12-volt bus, and then there's this wire, focus, there's this wire up here for video, which is nominally for 75 ohms analog composite video, but we took a look at some of the trace routing on this last time, and it's really routed all over the place. The ground is just nowhere nearby, and so the signal integrity there is not really a thing. But I do want to maybe repurpose some of that for, well, maybe I'm getting ahead of myself. Basically, I have a plan to save a little bit of space by removing the video wire going through most of the joints. And then in the last joint, I had this problem where I want to get 12 volts to the end of the gimbal for my camera, because the camera I'm using runs much better off of 12 volts than off of something lower. And the very last joint where the camera would need to be mounted doesn't have 12 volts because it doesn't have a motor. It just gets 5 volts for its inertial chip. So my idea there is to just repurpose the video wire on that joint to carry 12 volts, make a small change to the circuit board on the joint prior to it to route 12 volts into that, sorry about the focus, to route 12 volts into that thing that would have been the video wire. So the upshot of that is, in all of the joints except for the last, I can remove the video wire and use that area inside the joint that I've saved for the coax. And then in the last joint, I've already got one fewer wire going through there than all the previous ones, just because of how this was designed to begin with. So I can just add the extra coax there, and I don't think it'll be a problem. So that's the long-winded explanation of the plan here. This also might require disassembling this a little bit more, because you can see here, it looks like what they've done is, focusing, it looks like what they've done is this is just a cable that's kind of stuck down into a milled channel in the aluminum, and then they put like a nice sticker over this. I'm probably gonna have to destroy the sticker to put my coax under there, but that's fine. If I need to, I can put some gaff tape over it or something. But it is a very nice look. So yeah, so far I haven't taken apart the middle of this. I've just taken apart, this is, I think this is the side that would normally go to like the quadcopter end of this, and this would normally go to the camera end. So on the camera end, where is it? It's in this bin. See if I can focus the cat. He's way over there. You can probably see him. So on the camera end, it has this little contraption. So let's see, this cover, and all these parts are nice machined aluminum. So this cover fits on top of there, and this motor plugs in there. I don't actually want to plug it in right now because I don't want to wear out the connectors, but you can imagine that cylinder fitting in the hole. And then, oh, that's a better shot. So this is the last motor. This is the one that's actually directly holding the camera. You can see, oh, also this shiny thing that the wire is passing through last, that's the magnet. That's what's used for the angle feedback, the magnetic encoders. So then this is the kind of business end of it. Normally the way this would work, that would be attached to this. Focus. Let's maybe do this manually. Oh no, now it's wobbling. Calm down, little camera. Okay. So normally this would, this would go roughly like that, and it would clamp your camera in there. Let's focus this a little higher. Yeah, oh, that's better. So this is actually a pretty tidy little package. So this metal bracket combined with the little screw-on clamp holds the GoPro. This thing screws on there. So, I mean, it seems like a pretty nice modular system. My first thought was, oh, I'll just machine a new bracket that holds my camera and put that on there. But I think I found a much simpler solution. There was also originally a sticker covering this, but it was, that was designed such that you could take that off and stick a wire in there to attach power and video to your GoPro, assuming you didn't want to just run it off of batteries all the time. So then this thing, the way this normally fits together, the camera bolts onto this little bracket, then this bracket bolts go through this and then into threaded holes in the motor housing. So this black piece here is actually the motor housing itself. The inertial sensor on this board, this board has the inertial sensor, and the board is just glued onto the housing to keep it rigid, I guess. And then screws just pass through here and then into those threaded holes. I think these are all M2 fasteners. So I think what I want to do actually is just replace these screws with something a little longer and put the screws through the camera housing and then into this whole assembly. So for that, we need to look at the camera. So actually, if you haven't seen it, there's a pretty awesome teardown of this camera from Kenneth Keeter, which you can find on Google or on the GooTubes or whatever. The particular camera, I'm trying to find the back of it. Here it is. It's the Crazy Fire HZ100P SDI. The upshot of it is it's an inexpensive, small camera that will do nice looking 1080p video over a coax cable that you can extend pretty far. So these cameras are designed for basically like high-end security camera systems, I think. And it's like 80 bucks, I think, or a little less. And this is the wiring harness from the back. You can see it usually has this pretty bulky thing with like a little joystick that you can use to operate an on-screen menu for changing, white balance settings and a bunch of other stuff. It'll output composite video, which we don't care about because it looks terrible. And it outputs SDI video, which is what we've been fussing around with trying to actually get through the gimbal. And this stuff is great, but it's, it's kind of challenging because you're dealing with a digital signal with a bit rate of 1.25 gigabits per second. But it's actually a lot easier to deal with than something like HDMI. So compared to something like the GoPro, where our choices are choppy Wi-Fi that's always going to cut out, or HDMI that's going to be even more of a pain to, to move over a long wire, this is actually a pretty good solution. And it actually has some pretty nice optics. It's fixed focus. Well, it's adjustable, but it's manual, I guess I should say. So this is the lens, which you can see I've already taken off. And so it's got sort of a wide-angle telephoto control and a focus control. It would be nice if those are motorized, but that would probably be way too heavy. It's actually probably something that I can set and forget pretty easily. This is the front housing. One downside of this camera is it's actually pretty heavy as far as these things go. So the GoPro has a plastic housing. This metal housing is probably pretty nice for stability, but it's probably unnecessarily heavy. So I'm considering not even using the back of the housing. Maybe 3D printing a little plastic insert that just covers up the hole. Or maybe just leaving it open depending on how I feel. Probably 3D printing a strain relief for the wire is actually the way to go. Well, not like a strain relief so much as like a cover and a guide, since hopefully the wire is not experiencing like external strain. So I think this is aluminum. The main features that we care about, the circuit board mounts on these little brass standoffs here. So there's actually a lot of not especially useful space in here. So I don't want to get out the board just to illustrate this point because it's in an anti-static bag and it's got a sensitive exposed sensor on it. But the board sits like right at this level where my finger is on top of these standoffs. And then there's actually a significantly taller amount of standoff there that gives the screw anchoring the back panel a place to hang out. So basically, if you imagine, I need the other piece to illustrate this next point. Where did I put that? Oh. So, okay, so here's the back panel in its kind of usual configuration. Really hard to photograph all this shiny black metal. And so you can imagine the camera, in the configuration I had it for just testing, where I was just like taping the camera on, it was sitting kind of like this. And it kind of worked, but really to get a better, really what I'm optimizing this for is center of gravity at this point. The lens on this camera is pretty heavy. So with the lens attached, you know, that with the motor right here, it's got a pretty long lever that's just trying to torque the motor that way. So even just pulling it up, I mean, it was kind of hard to tell how bad the problem was because I still had the cable attached to the camera at that point, and the cable was also fighting against the motor quite a lot. But basically, I think what I want is not to have this bracket at all, because it's not helping. And then for this, I think I want to actually set this back quite a bit. And so then what that leaves me with is, if I do that, that screw hole is exposed, so no problem there. And then if I can set this up so that, I mean, so now I'm looking at the circuit board there. Basically, I want to put this kind of as far back as I can, and then drill 2 extra holes in this housing so that I can put some somewhat longer screws through these holes and then through these holes and then into the motor housing. So I have something basically like this. So my constraints here are mostly, I want this to be fairly far back for center of gravity. I also want, well, I just want the holes to not, or the screws to not get in the way of the circuit board, and to make sure that this one is actually accessible. So this would also be maybe slightly easier in CAD, but not worth making a CAD model for this little step. So it's unfortunate that I don't think I can get the screw to really fit below the circuit board. I think the screw is going to have to be above the circuit board. Let's see how much room we actually have with the circuit board. Let's get out the circuit board. I stuck that in a bag. Catching up on chat, and yeah, a couple of people are suggesting that I'm going to need better balance given these motors with more counterweight. I guess it depends. I mean, what do you mean by more? Like to shift it back further than what I'm showing currently, or to like add more weight, because it's already heavier than I really want it to be. So I don't want to add more weight. I think I want to deal with this by shifting the weight that I have. That's the image sensor. Cute. So I think this board is going to get pretty close to the edges of the housing. Okay, housing. Yeah, so that's basically what we're dealing with. Yeah, while Mania is explaining how center of mass works, that it needs to coincide with the x and y axes. And yeah, that reduces the load on the motor at idle significantly. I guess what I'm trying to say is I tested this already, and it was already pretty close. The main difference was that forward and backward. And I'm planning on solving that by drilling some holes here, hopefully. But yeah, I might have less room for these screws than I would really like. Here's the motor. Yeah, I think if I move this far enough down that the bottom screw is accessible, then the top screws become inaccessible, unfortunately. That's annoying. Alright, well maybe I think about that problem while fussing with micro-coax. The other option I've been considering is to just replace this housing with something custom. Preferably 3D printed, I think, because I don't really think I want the weight of all this, really thick aluminum, but that makes it really hard to hold the lens reliably, So I'd like to use this housing as is. The housing's kind of nice, it's just heavy. And the main problem with this is, I could find all sorts of different ways to just attach these two things to each other, but I need some way for these screws to be accessible so that this piece can then attach to the motor. But yeah, And so if I did have some kind of bracket, would this, how would I want to actually attach this? So there are already some little threaded holes in the side here that were designed for like a little mounting clip. So that could potentially, so ideally I want that to be somewhere like that. I can measure the actual center of gravity if I have the freedom to position it wherever I like. And so then I probably end up wanting to make a little plastic piece that has, I think, probably like a retaining loop that fits around this piece, or possibly even a replacement for this cover. So that, and then some way to, yeah, I could imagine not using this piece either. Use this piece because I need the lens mount. Oh, careful with that. I need the lens mount threads for this to really be, for the lens and all this to be easy to mount. So now, at this point, I just need something that gives me a standoff that puts pressure only on the parts, only on the exposed points here. Man, for that actually I might need metal, because this actually does have some pretty narrow pressure points there. So maybe I need to keep this cap for structural reasons. And then, so assume that I keep this cap as basically a spacer, and then and then design something 3D printed that fits over this. And it can actually be kind of arbitrarily chunky over the motor. Like it can even like cover this, like this connector if it needs to. This whole black portion is spinning with the motor. The silver portion is on the other end of the bearing. So then, it would basically, in the print bed, it would look something like that. And I think it would then have like a little square cutout for the, yeah, I think this is sensible. So maybe this is not so much a drill press project as another 3D printer project. It's a shame, because I was hoping to use the drill press tonight. Yeah, this is almost a really simple matter of just putting some screws in here. Also, so where is the center of gravity on this? Like, where am I talking about actually mounting this? I think to get that, I have to put the lens back on. Oh, Kenneth in chat is suggesting a drill press option. It's just a little piece of bent metal as an arm that goes from the cap on one side to the camera housing on the other side. How would that work? Let's see if I can envision that. Well, I think this is when I need to know where the center of gravity is, but yeah, I think I can see what you're talking about too. Like, just like a little L bracket even, a very tiny piece. I can imagine that being super wobbly, but again, this isn't being vibrated. This is all going to be moved around very gently. So, like, this gimbal is not going to be under a lot of the stresses that it's usually going to be under. It's going to have a fairly gentle ride, but I plan to use it much more often than you would be using something like this on a quadcopter. Okay, so let's put a few of these things back on. I really don't like these standoffs. They're super annoying to put in. Like, I have to put them in and take them out with pliers usually. I don't have like something that'll grab these and put them in, so maybe I can replace these with screws for the moment. I wonder if these are M2, because they kind of look like the same size I've been dealing with on the gimbal, which are definitely M2. They look like M2. Got this cute little kit of M2 screws. Let's see if these fit. Got a couple of requests in the channel for the drill press option. Didn't know that would be so popular. Yeah, well, I like that too. I mean, I think it's mostly just a matter of, well, let's see. So if I do that, what material do I use? I have like a big bin of scrap metal for exactly this purpose, so I could probably find something. Let's see, is this screw too long? Yes, the screw is way too long. I need a much tinier screw for this. Keep thinking screws need to go through something. These are like circuit boards. They're very thin. Maybe I don't have anything less long than 4 millimeters. These look too long. Maybe I'm sticking with the standoffs. Maybe I will put these on top of the standoffs just so that I have something to grab them with. Oh, speaking of 3D printing, that seems to be going along fine. It's the other half of the spool. Where's the cat? Oh, he's in a great spot. Let me move the camera. He likes it over there. I don't quite know why. Like, I mean, it's probably comfortable and relatively far off the ground, which seems good. It doesn't seem like it would be especially warm, but I don't know. Maybe I'll have to point the thermal camera over there. Oh man, where did I just put that down? 3 standoffs right here. There's one that I was just putting a screw into. Oh, under the camera. Oh, this is much nicer. These screws actually fit totally into the standoffs, so now the standoffs have convenient handles that fit into a screwdriver. Yay. Wild Mania in chat is noticing the megapixel sticker on the lens, which is pretty weird. Yeah. Yeah, there's a lot of weird advertising on the... So like the lens says megapixel and IR, and the housing says wide dynamic range, but nothing else, just WDR. It doesn't even have the name of the camera. So it's like, this is a generic housing for wide dynamic range objects, some of which are cameras, some of which might be SDI security camera type things. This also seems like it might be interesting to reprogram. It seems to have like a JTAG header exposed, and it's capable of, you know, on-screen display kind of stuff. I'm planning on probably not having any access to the original button controls on this camera, but you know, if I want to get some of that back, I could probably do that either via firmware hacking or via sticking a little micro on this board that emulates the buttons and then speaks serial. Or there might have actually been some serial option in the firmware. I think I vaguely remember something like that, but that might be something from a different camera. Yeah, this whole big header down here goes to the little wiring harness that has all the buttons. All I care about from that, I think, is going to be the 12-volt power input. Then there's this little, some kind of surface mount coax connector. I don't know what that one's called, but that one led to the original SDI. The composite video, they just didn't even bother with coax. It just goes over the same connector that the power and the buttons go over. The SDI, they used fairly nice coax the whole way. I don't have the connectors for that, so I'm probably just going to have to solder my tiny coax directly to the circuit board there, or even directly to the connector if I don't want to have to remove the connector. Oh, Bob in chat is asking if my cat stays inside all the time or if he goes outdoors. Kind of, sort of in between. He doesn't really go outside, but I live in this kind of warehouse building, so he goes out into the hallway and hangs out with the other tenants and the other shops nearby. So a lot of my neighbors have cats, and he'll hang out with my neighbors' cats and hang out with them. So he'll ask to do that usually a couple times a day. He's pretty big fan of going outside. And so when we talk about going outside, it's not usually actually going into the outdoors. It's usually going into the rest of the warehouse. Although I have taken him to the park, but only like once or twice. It hasn't been a common thing for us yet. Okay. To do this right, I'm gonna really have to focus it, but I think to set, just to set the center of gravity, I will just put this in kind of an approximate location and not worry about actually focusing the lens. Because when we're talking about that kind of granularity, like the motors are going to have to deal with the center of gravity changing a little bit if I change the zoom level, for example, because the lens elements all move quite a bit, actually. So, and might as well keep the lens cap on, it's pretty light. So there's the camera. See if I can get something to balance this on, like a ruler. What do you say it's actually there? No. Oh, actually it's pretty close to right there. that joint between the lens and the body. Which is pretty far forward. Let's see what that looks like with the motor in place. That would be like right there. I would need to take care to keep, that just barely clears. So that's the thing I have to watch out for. I can't really dig in past the edge of this housing. I have to kind of keep this plane clear, otherwise I interfere with this control. I mean, potentially. I mean, maybe I can rotate the lens, so that's not an issue, but maybe I don't have that freedom depending on where that set screw ends up having to hang out. So anyway, yeah, so I want to line up this axis basically with this plane between the two elements. And that's pretty dire. Although, I mean, it's almost such that, like, if all of these screws are accessible just by taking the lens off, then I could even just epoxy these two pieces together and it would be fine. Like JB Weld or something. Because that would basically amount to, joining that little bracket with the camera housing, kind of roughly like that. Maybe I could even, I don't know, there isn't really room for another fastener in there. I would want to use these existing holes if I did anything, but yeah, I mean, maybe what I could do then is have a little bracket that I do with the drill press and then also use some epoxy to reinforce it. So, that's looking good. I'm just looking at this from the side again. Let me see if I can get this on camera slightly better. So if I aim to position this, can we get this not to just look like a uniform mass of black pixels? So basically I want this, if I constrain this so that those bottom screws are accessible via the front, then I no longer have to design this as something that's like really disassemblable. I can just epoxy these together. So I like that. Because otherwise, I think just that bracket, I would worry about that being rigid enough. But if I can have that bracket and then also reinforce it with epoxy like along the faces and like along the sides here, then I think that might actually have a chance of holding up all right. Oh, let me see if I can check, if I can pull up the chat here, because there are some suggestions floating around, and see if I can actually get those on this computer. Which computer am I even plugged into? Here we go. Okay. Yeah. Yeah, that seems nice and simple, actually. So, like that, like, yeah, I guess there are a couple of different suggestions that have been floating around in my head, in your head, and I think we're converging on some similar ideas. So, like, one of the trade-offs here is using the original holes versus using. So if we go back to the camera, where am I? Here we go. So, you know, these holes are probably convenient, but actually, you know, these holes are actually probably stronger overall because they go directly into the motor housing. You know, this is actually relying on this little piece of aluminum, which, you know, I'm sure is fine, but, you know, if I can have like a plate mounted through here, and I have longer M2 screws, so like that's not going to be an issue, then like I think the only downside to that is that I end up moving the camera further from here than it really needs to be. Since in the original bracket design, the camera can actually sit just like flat against this, which is kind of nice, but definitely not required. So then, yeah, I guess basically the two options here are, you know, either way, the fit is basically like this, but either there's kind of an L bracket that sits in that unoccupied space right there and attaches via those 3 screw holes we can see, and then I have the option of reinforcing it with adhesive if I want. Or there's a little bit of extra space, there's a metal bracket there that goes through those 3 holes and that hole, and I can still glue it on the camera if I feel like it. So, sorry, I was just catching up on chat, but I should share with the class here. So, which mouse am I even using? Let's avoid having the giant feedback. Oh, let's make this actually visible here. Yeah, I like that suggestion from Kenneth. Maybe punch another hole in the camera housing, because yeah, that one little hole is not super happy. Yeah, little bracket with a 90-degree bend. That definitely seems like what we're talking about. Please draw out your ideas in MS Paint. Well, I think Kenneth already gave us a pretty good MS Paint. Like, I'm liking that. I like how you signed it. That was good. And I think the other option is if I can scribble on top of this. Do I have any scribbling software on this computer? I think I have scribbling software. Now I just need to figure out how to actually make all the computery bits do the computering that they need to computer with. Oh man, I don't think I have Photoshop on here. Do I have like Paint? That isn't even the right keyboard. I think I have like all the 3D programs on here, but not the 2D programs. I have MS Paint. I could literally use MS Paint. Do I have to paint.net? Well, whatever. I haven't used MS Paint in ages. Maybe this will be fun. Yeah, man, Photoshop is on like all the other computers. Different versions of it. Like I've got a not so ancient Photoshop for Mac and then a much more ancient Photoshop for Windows. How do I zoom? Oh, the mouse gets like almost impossible to see when I'm over it because their crosshair is very subtle. Okay. So yeah, basically what I'm saying the alternative is, let's make a copy here. I want to zoom out. Oh, is it way over here? That was, do I only have the option of 50% and 100%? That's kind of drastic. So same position basically, except actually it wasn't this. There was still some overlap here, so there is still a place for it to glue. So yeah, there's a little bit of overlap. So I think really we should do something like. This. Oh man, I feel like I'm trying to drive a golf cart with boxing gloves on. So kind of like that. And then let's copy that. It just feels like it'd be wrong to get out the graphics tablet to use that with MS Paint. So then here, and then can I draw? It's supposed to be more L-shaped than it actually looks. In true MS Paint fashion. So, God, that's terrible. Can I undo? That was worse than it should have been. Maybe I need that good old-fashioned 100% zoom. This is, I should scratch out this because it's no longer, I don't want to have him blamed for this abomination. Credit for the original, for sure, but, you know, blame where blame is due. So yeah, I think the alternative is something basically like this, and then screws and/or glue as we see fit. So how much do we care about that offset difference? Is that an issue in the slightest? So. I hope you don't mind me scratching out your signature. No offense meant by that. I just, I personally wouldn't want my name on that. The modified version, of course. So let's see. I think I will temporarily put this back together slightly so that I can get the axes straight. Or if I put back together, I mean with tape, not with screws, because that's how I'm feeling right now. I mean, I don't have to worry about, like, self-tapping screws wearing out the plastic on this, but, you know. So, and how does that hang out? So this So basically everything attaches to this motor bearing. This housing attaches to the motor, sorry, that was off camera. So this housing attaches to the motor bearing here through these 3 screws, and then this housing through these 3 screws. Okay, that's all we care about assembling right now, I think. This is all very janky without the screws put in. Just trying to get a sense for where. So this is the top. This is the back. Okay, so the front is to my left here, the way I'm holding it. And I feel like this is like a real-world object that should just have an XYZ axis hovering next to it at all points for debugging. Like I should just compile reality with that option enabled. All right. Simulated. Holding things in position. So basically like this. So this is already kind of far off center from optimal. I mean, it's less bad than the original GoPro. Like the GoPro lens was like way out here, but you know, ideally we should be keeping things as close to here as possible, which probably explains why they designed this bracket to be super skinny. So that points toward the L bracket approach, if I can figure out how to actually manufacture that. Oh, that's great. I need to implement a suggestion from Kyle in chat. Oh, that was the wrong keyboard. Let me use the right keyboard. Basically that. So yeah, something like that. So I mean, ideally this wouldn't be made out of just a flat piece of something, because that would be prone to a lot of wobble in the direction that it's bent in. That's less of an issue if we can just goop it over with epoxy. The really posh way to do this would be to have a machined aluminum thing with some like nice structural pieces like they've done in the original bracket. But that's probably way overkill for what we're dealing with here. Oh. This is dumb, but maybe let's do it. Actually, here's a third option. Let's have these get a little closer together, because I think we're going to need some more room. So, no, there is no proper zoom level. Is there anything in between 50% and 100%? That is weak, Microsoft. This is like back from the days when the browser had no ability to scale things. I mean, and this isn't even like original MS Paint. I mean, original MS Paint was way less capable than this, but anyway. Now I'm starting to sound like I need to have a lawn to tell people to get off of. How do I things? this mapped. This thing where I'm using like Linux and Windows and Mac all simultaneously on the same computer lately has totally screwed with my ability to remember any keyboard shortcuts. Where did the actual paint part of paint go? Oh, there it is. So, how do I embiggen my brush? All right. This is gonna blow your mind. Ready? Oh yeah. Check out what I just did. So I think there might actually be enough room for this. So what this implies is that I drill holes in this front face of the camera and then use those existing holes in the motor mount. And then I also need a hole in that front face to pass the wiring through. But that actually would be really rigid and would solve my horizontal problem somewhat. A noble spirit embiggens the smallest brush, yes. Yeah, this does make the focus and zoom problem harder. Let's see if there's no way to make sure that I have the controls on the other side, is there? Well, actually, I don't know, because I mean, I could have, like, if I don't mind having to artificially impose like half a turn's worth of focal length distance on my lens system, like this has a lot of room to focus, so I think it'll be fine. But let's just actually power up the camera and see how much of that we have just to test this before we go too crazy with the drill press. But I think it'll work out fine. Oh, also, yeah, a couple of people in chat, Andrew and US Water Rockets, are both suggesting to just remove the controls. And yeah, that's actually totally true. These just come out. These are just set screws. In fact, are these also M2? Can I just stick a little M2x4 in there and finger tighten it? Or tighten it with the like angled end of an Allen wrench if I care about tightening? Yeah, this is the obvious solution that I was failing to see, but now everybody in chat's suggesting it. Now, are these M2? I think so. I think they standardized on M2, which is really nice. I really like metric screw sizes. I really enjoy designing with them. Oh, that's great. Oh, so that's wonderful. So then I can just set these with an Allen wrench if I need to, and it's fine. Great. Perfect. So in that case, I'm going to take the lens back off and see if this actually, well, no, not take the lens off, but I think take the circuit board. Oh, now I'm just jabbering. I want to make this simpler. Let's take this part of the gimbal off of the thing at least. And that actually just lends itself to a very particular location. So one thing that's kind of weird about this is the case front is angled. So this would mean that the axes are a little bit misaligned, but I don't think I actually care. I don't think I care at all. Like, if I really care, I can probably figure out how to correct for that in software. But I don't think I care for that little of a difference. Oh yeah, now there's a suggestion in chat to mill it to be flat, which yeah, I guess I could do that too. Because this material is pretty thick. There's probably a good amount of room to take that off. And that would certainly make it easier than trying to drill it on a bevel, which seems like a recipe for trouble. Well, maybe I'm doing this on the other mill. Is the other mill tall enough to fit this? What is the actual Z spec on the other mill? Let's look that up. With the spoil board installed, 34.3 millimeters. So what are we dealing with? Calipers are at my other desk. Be right back. Oh yeah, this will be fine. There's plenty of room. Even at its tallest, this thing is like 26 millimeters. And the part that we need to work on is like 20 millimeters. So yeah, maybe this turned into a machining project. I mean, if I need to machine this to make a flat, then I might as well do the whole thing on the mill, probably. Well, okay. I guess what this needs then is I need to model a stock material in Fusion 360, which is kind of a rough model of this. It could be a little oversized, but that's like the material that it needs to know, that it is there. And then model out the actual features I want. So I want to make a flat for this bracket to sit against, a little, like a cutout for the wiring, and then 2 holes for the actual mounting holes. So yeah, this should actually be good. I mean, I'm kind of optimistic this project will work out pretty well at this point. And this might be a nice combo, like if anybody else wants a camera that you can get video out of and actually aim, that, if there's a way to adapt these two things. I mean, it's nice having this metal construction. It should be pretty solid once it's all put together. So, I'm going to take the electronics back out of the camera, and then we can get into CAD land and start modeling this up. Let's keep this screw. This screw set is so meticulous. Like somebody was like carefully labeling these little bags of screws, and I want to keep them mostly in order at least. It's so weird when you listen to some people talk about, some piece of goods that they ordered, like some object that they paid money for, and then someone else made it and then shipped it to them. Like there's such weird feelings associated with that act of labor. It's like people either expect it to be all made by machine, or they expect it to be all made by hand, but then like, depending on context, people kind of sneer at either of those. It's like sometimes people don't want to imagine that there's any labor involved in the things that they enjoy, but then sometimes they don't want everything to just be like churned out by machine. But then in reality, everything is just such a blend of the two. Like everything is made by so many machines and people working together, and so many machines that had so many man-hours put into designing them and operating them. It's also why I like watching teardowns of like random junk from eBay, but I also like considering the context in which it was made. Like, oh, maybe this was actually a really good way of getting rid of some parts that they didn't otherwise have a home for. Oh, this isn't going to make it easy to get the standoffs out, is it? Oh well. I still need to use the pliers to get these started. I don't know what the proper tool is for this. Like, is there some kind of... Because, like, it's not a hex profile or anything. It's just like a knurled standoff. So, Like, I mean, they probably just did not design these to be taken apart, because for putting them together, you can probably just do something kind of like what I did with the screw, but I don't know. Be curious to see what their assembly line's like. It is annoying to take these off. I think I got that one started though. I could also probably put a dab of super glue on the screw, and then that would make it easy to get the standoffs out. Kyle says, you've just got to switch between additive and subtractive processes until you get it right. And yeah, I think it's super useful to have both kinds of tools available if you can manage. So yeah, like if you're hackerspace or home shop or wherever you have the privilege and, you know, enjoy working out your mechanical problems, like it's really nice to have both kinds of processes available. Okay. Carefully put this somewhere anti-static and also not scratchy. Okay. So many keyboards, none of them correct. Oh man, I actually need an extension cord for this keyboard. The wire is really annoyingly short right now. Wireless keyboards are so hit and miss around here. Like, I can use them some on the other side of the room, but like over here, there's, I think, just too much electrical interference. All right. So that's our design. Sure, I guess I'll save this. Why not? Oh, nice. That sounds neat too. Yeah, so I'm questioning that too, like whether we're milling through the material. Because yeah, I mean, it's really thick, but yeah, we totally might be. But let's at least try to model this and see what we're dealing with. I think any way forward, I think having a CAD model of this piece of the case is going to be useful. This is also appealing to me, modeling a new case with the correct geometry. I like that a lot. The main challenge there is that it would have to be made of metal, probably. Like, unless I can find a way to mount these lenses with 3D printed material. And for that, I'm just not really well set up to machine something that big here. I think it would be asking my other mill quite a lot to make a piece this big from scratch. Like, I think it could do it, but it would take a while and might not be the best tool for the job. The other issue is this really wide threaded hole. I'm not sure how I do that here. Like, maybe I just have to mill out something that big and then buy a tap that large. That seems frustrating, but, like, you know, doable. But But yeah, the main reason it would be nice to use this existing piece is the you know, the interface between the lens and the circuit board. Oh, why not 3D print the case and then tap the hole? Yeah, or glue the aluminum lens mount on. I mean, those are options. That's also a good option too, making little wedges to flatten the angle. That would be interesting. Yeah, that's also a good suggestion. If the metal filament hybrids have sufficient hold for threads. So, yeah, I mean, it would be an interesting project to try to machine a new version of this bracket, but it seems like it'd be really hard. And like, I'm not saying I won't go there. I'm just saying I'm going to look at the other routes available before I decide on that one. So let's open up some CAD here. I will keep an eye on the chat. We'll keep that handy. I really appreciate all the suggestions. It's nice to have some company in solving these important camera related problems. Fusion. Firing up the fusion engines. US Water Rockets is suggesting a Harbor Freight metric tap set. I mean, yeah, I could tap it. I don't know if like a normal tap set has taps that large, but I guess, like, okay, how large is this? I'm going to measure this. That's looks like a 12mm hole. Maybe 11.5, depending on how you measure it. But yeah, that's like larger than most bolts people would use. So like that's why it seemed to me like it would be more of a special purpose tap. But like, you know, I'm obviously not a machinist, so. And yeah, it does have to be pretty dead on, I think, for this to work out. Like, part of why I chose this camera is it has nice optics and nice image quality, and I don't think I want a plastic lens mount messing that up. So. Oh yeah, and Wildmania in chat also mentions that the lenses only need to move 90 degrees, so I just need to rotate the whole lens holder. And yeah, and I mean, I was thinking about that earlier, but my concern there is how much that shifts the focal plane and whether that's still something I can compensate with. I think it is. I just would want to check that first. So I think it's fine, but just trying to think ahead and not paint myself into too much of a corner here. All right, let's just make a new project here. I guess I already had a thing here. What's the name of this camera again? HZ100P housing. I'm sure this housing is actually pretty generic, but since I don't know what the housing is called, I'm just going to name it on this thing. Yeah, so far my favorite options are either the little wedge spacer, or if I can just design a way to flatten it enough without taking off so much material that I weaken the structure right there, and then reinforce it with some epoxy. Because the camera housing is actually really thick. That's just the only reason I'm entertaining that possibility, but you know, it's certainly possible it still isn't thick enough. All right. So, I think I want to start with the outer surface. It looks like the outer surface here was probably designed to be more, well, I don't know. I was going to say that it was designed to be more accurate the way this mold was machined, but who can say? I mean, somebody can, but not me. It looks like the outside Let's get the other camera on screen. So 42.3, and is this tapered? 42.4, 42.5, 42.2, so there's a slight draft angle there, which probably have to maybe slightly take into account. Is this square? So that's 42.5 at the bottom. And I rotate it. Also 42.5, so it does look like it's square. So let's start with maybe a side profile of this so that we can get the tapers right. Alright, so we've got a sketch on the front. Let's make a rectangle. I still don't quite get how midpoints work in this software. But, like, the midpoint tool seems like it requires both things, or like it does the midpoint of both objects that you've selected. But that's not really useful in most cases. I guess in that case it works out because I can select a line and a point, and then the point, its midpoint is just itself. So now I've got that. Except this is not actually parallel. This is going to be a construction line because that's not real yet. These two are real. Let's go ahead and put another line up here. I'm not really going to bother modeling the, well, I probably do need to model the, basically the width of this section up here. So I don't really need to care that much about the details of the lens mount unless I'm making this thing from scratch, which I'd really like not to. But since this is probably where I'm going to be measuring the slope, I care about this diameter. So this outer kind of circular piece, if I measure this at this diagonal where it's the minimum this is going to be annoying. I think actually, well, luckily this is circular, so it doesn't matter where I measure it as long as so I was kind of worried about it being slanted on the sides. Anyway, I think this is the right way to measure that, to get the measurement I want. So that looks like 16.6 millimeters. Some of these I'm rounding based on like assuming that that might be what they intended, but 16.6 is probably a good value to use for the moment there. And let's resymmetricify this. Okay, so I want this midpoint to be on this line. So that's not what I want because that uses both objects' midpoints. If I say coincident and I want this line and this midpoint, but I can't select that midpoint right away. So, meh. If I Can I sketch a point at the midpoint? Yeah, maybe that's what I need to do. And then just have that point and that line be coincident. And this should be horizontal. I think that was already perpendicular constrained, which is fine. Okay, so now I want symmetry constraints, I think. Now I'm trying to pay attention to chat and also look for the constraints, which is difficult. Okay. Oh, did I over... Okay, I think those are the constraints I want to start with for the moment. Now, I measured this already. Oops. Let me remind myself what this was. 42.5 millimeters. That's a little extreme. So, what else? At the top, we have 32.2 millimeters. Little angles. And height. This is all a little rounded, so it's hard to get this exact. Oh, but it looks like it's pretty much exactly 19.5. So let's go with that. So for this, oops. I need distance between two lines. Yeah, so that is not on a slope. That is a parallel, or perpendicular distance between those two lines. So now, I think we're just dealing with this. Oh, this caliper doesn't quite reach across the bottom of the box. Looks like 22.22. I don't think that's quite right. $22.7 is the number we're looking for. No, I wanted to select those two lines. Okay. So we have roughly that. So I think what I want to do to get the closest, well, a close enough replica of the shape is to basically just extrude this twice and then intersect the two. I think that'll do what we want. So let's just make 2 arbitrarily large copies of this. Yeah, move, copy, bodies. And the pivot point just needs to be the middle of, well, only some of these axes matter, but the middle there is fine. And make a copy. Oh, that was setting the pivot point, not the, not actually rotating it. There we go. Oh, let's change this to be perspective. There we go. That's our thing, not quite square, or not, I mean it's square, but these sides are not quite vertical. All right, so now as far as thickness, I think what I'm going to do is, well, let's measure the sidewall thickness and then measure the top wall thickness, and hopefully they're the same and they've tried to keep it uniform. And we can just make a uniform shell, otherwise things get a little more complicated. So that looks like 1.4 millimeters. Looks like 1.4 is probably the nominal that they're trying to hit there. And we already measured that. So I'm just going to measure this. Let's actually get that on the sketch first. So this, I want a line. This will be the thing that I'm measuring. .28. Let's call it 18.3. Let's take this project it. And what do we got? 1.2. That's a good sign. So, I mean, close to what we're measuring, and either they actually made it a little bit thinner up at front, or it's just, it seems thinner based on how I measured it because of the rounded edges that we're seeing. But let's assume for the moment that it's a uniform 1.4 and then see how bad it is. This might be a wrong assumption, but it'll get us to the next step. All right, so here I think we can just make a shell. 1.4, right? I mean, it's a little thicker than 1.4 on the sides, but I mean, it isn't quite, yeah, it isn't super uniform. In parts, it's 1.39, 1.37. Anyway, whatever stock I make for machining to start with, like, it's probably going to end up having, you know, a little bit of, like, I'm probably going to have to design the tool path so that I don't need this to be extremely accurate. And that's the right direction because all the measurements I just did were on the outside. Okay, cool. So that's what I've got to start with. Now let's model, let's save this. Let's model another piece, which is our bracket that we're attaching this stuff to. I don't need to model this in a lot of detail. I just want the interface, really. So it's this little piece, and really I just care about, oh, you can't really see it because it's all so dark here. There we go. These two holes and this cutout. I pretty much just want a model of that. Because that, like, this area here is a pretty good suggestion for what to maybe mill out for the wires. Like, it doesn't have to be all of that, but it'll be something in there. And then having a nice flat area for these two squares to sit is really important, and to some extent this piece right there. All right. Front? Sure. Oh, we got another diagram in chat. Let's see. Let's see, I need to catch up on this too. So we've got a diagram. Some URL testing. Okay, let's see what this is like. Megapixel. Ooh, this is the Hake wedge. Oh, that's nice. Countersunk, OMG. Oh yeah, that's good. So then, yeah, that would probably do the best job out of anything here of keeping the screw from getting in the way of the circuit board. Yeah, and I wouldn't even need to machine this. I could just 3D print this. That would save some time. I mean, not just time either, but machining these subtle, like if I wanted to machine this, that would be difficult with the tools I have. Like I have flat end mills, I have a couple of fixed angle tools, but like for something like that, I would have to approximate it and then like file it a bunch afterwards. Yeah, the Hake wedge. That sounds like something you would use in your keyboard. Like, when someday I finally grow up to be a cyber woman holding banana or holding corn, then maybe I'll use my Hake wedge to connect my cyber corn to the interweb. That seems like something that would be important in the future. Yeah, so I like this a lot. This is oh, and you're not seeing the full glory of this diagram because it's cut off a little on the bottom here. Man, my buttonage is sometimes suffering from an off by one error here. This is totally not supposed to be. That's fine. It's fine. I didn't need that project to work perfectly. Actually, I kind of do, but I can fix it. So yeah, countersunk, OMG, yeah. What do I have in terms of screws? I have a bunch of these not countersunk screws. Could I reuse, like, what screws did this use? These were pretty short. But yeah, I mean, I can get more screws if that's the limiting factor here. I think this is one of the screws. A couple of different sizes of countersunk screws, but they're mostly pretty different. Let's hold everything and get it all in focus. I think these are going to be it, because yeah, these screws seem longer than they need to be, but I suspect they want this connection to be fairly secure. Yeah, that seems right. So, so we want a lot of that screw to still be biting into that material. What does that look like? How much room do we actually have in there? Calipers. I should maybe also have my mock-up include, like, where is the circuit board? It's a pretty rough measurement, but, oh geez, I can do a little better than that. There are these little mold release pins that are right where I need to put the caliper. I was going to measure the distance between that bottom floor and the tops of those brass standoffs. So it's roughly like that, but then I also have to kind of add the thickness of these little bumps. So the bump is like 0.8 millimeters. And then this on top of the bump is call it 5.7. Well, anyway, I'll just not add let's call that about 6 millimeters of clearance. That's plenty for a screw, even without something super countersunk. So I'm not going to worry too much about using my longer screws that have beefy heads on them. Let's see if there's any tall parts on the board that I have to worry about hitting. Where did I put the board? The board's in here. Ooh, could I make a hake wedge out of the GoPro mount? Huh. How would that work? That would... Huh. I think part of the problem is, so if I want to use its hardware, the hardware is not long enough. Using that metal would be interesting, but that doesn't really solve my machining problem. There's actually not a lot that's tall here. So... yeah, I think having, well, let's actually bother CAD modeling this, because I don't want to scrape the circuit board, but I think it'll be fine. I'm going to try out the hake wedge. It's going to be awesome. All right, what was I modeling? I was modeling that little bracket. Do I care about the bracket? I think I still care about the bracket. But I also want to go back to my other model and make some changes before I forget about them. I want to mock up the circuit board inserts here. I don't really need to care that much about where the circuit board standoffs are, but I want at least the level of the circuit board to be generally known in here, which I could maybe even do with a construction plane. It's not where I wanted this plane is in the way. Go away, plane. You're not even in the list over here for me to turn off yet. Grr. How else would I do this? There are many ways to do this. There was just the one that I reached for was making an offset plane from something that was already at the right angle, and then because I wanted to make a plane through this point down here and then offset it up by what I measured, which I was trying to do with plane. What was it? Plane tangent to face at point. Maybe tangent actually implies that they're touching and not just parallel. I think offset plane is maybe what I want in the language of this. But I was just having trouble measuring what I wanted. Maybe let's start from... No, I want to start from this one. Measure. How do I get that? Oh, if I zoom in, now I can select it. I guess it was patience and waiting for it to recognize that I actually wanted to select that thing that I had my mouse over for seemingly forever. Is it going to give me the same courtesy down here? No, it still thinks I'm talking about that plane that's way up there. Well, maybe I will just do this numerically. How long is this? 18.4-ish. Let's call it 18.4 minus... We wanted about 6 millimeters for the circuit board. Now I'm going to say the thickest stuff we have to worry about on the edge of the circuit board is 2 millimeters, so let's go up 4 millimeters from here. So we want 16.4. Negative 16.4. Okay. That is the plane that we have to not cross when we're designing the mount in order to not get in the way of the circuit board. Just label that. Okay. That's all I wanted to do. Now back to the other design, which I guess I haven't even saved yet. So now to model the bracket that we're interfacing this to. So this should be pretty straightforward. 19.8. That's the basic shape we're talking about. And then let's make can I have constraints for profiles too? What does this even do? I don't know what that did. I don't know if it did anything. Okay. Maybe drawing it that way didn't actually give me an easy way to set the constraints. Let's try that again. Maybe that's what I wanted to do. And then set a bunch of these equal. I think that's better. And then measure these a little more accurately and not just assume that I can round to the nearest 1/10 of a millimeter. I do want this to be, because I mean with the curves, like I couldn't really necessarily get exactly the right location for the calipers, but I was trying to infer like, okay, they probably designed this with these parameters. Whereas here, I just want something that will definitely fit this particular bracket. So this needs to be 4.88 probably. Let's see if that's the same on the other side. 4.86, so let's take the biggest of the two, so we want more room for the bracket. That's 5.17 on either side. Call that 19.82. I think 19.8 was closer. What's going on there? That's not what I want. No, none of that. Oh, that shouldn't have gone to the midpoint. Okay, so I need to measure that thickness and some hole locations. That is 0.85 millimeters. I'm not going to worry about, well, I always say that right as I start to actually worry about the thing I say I'm not going to worry about. I mean, so I want the model for this has two purposes. It needs to provide space for the flat parts to sit against, and it needs to tell me where to put the clearance holes for these screws. And so that actually gives me some flexibility with the design, like if I can if I can make sure to leave enough room in that clearance hole that the constraints elsewhere aren't kind of overly constrained. I'm just realizing actually that this solution, the Hake wedge that I've been excited about, this still leaves me with a very difficult drilling problem, but maybe it'll be fine. Maybe if I man, I don't have a proper center punch here, but maybe I can find a way to get that started, because it's certainly a bit of an edge, you know. I don't think the drill is going to do super well on there unless I mill a flat in it. Resymmetrify, yes. All right. Yeah, drilling at very specific angles seems difficult, and yeah, that front bevel is super annoying. I mean, worst case, I totally mangle up this case in the drill press, and it's still probably fine. at actually keeping the lens aligned. But we can at least continue the CAD model. CAD model is useful regardless. So these are going to be holes for an M2, but I'm going to draw them kind of large because we want them to be like clearance holes, not holes that they get hung up on. So I think 2.5 millimeters is probably about right. I'm also going to do my best to measure the centers, but centers are hard to measure. This is another case where, oh, this like snaps to exactly 2.7 millimeters. That's probably what they were typing in their CAD program. This is, I don't understand the way this is snapping. Like, I'm used to the way Rhino kind of generates temporary geometry for automatic snaps, and this is looking very convenient too, but it's just not something I'm quite used to yet. But in this case, I actually want to avoid that because I don't want to assume it's centered. I want to actually measure it. So, diameter, and then that was what I just measured, and of course I already forgot because I had to type in the geometry. 2.7, right? 2.7. Alright, then I think it's probably pretty safe to say this is symmetric. It looks extremely symmetric. I don't know why they would design it not to be symmetric. And then 2.5. Yeah, so that, the hole is not necessarily centered right there, but I guess I mean, like the bracket as a whole is symmetric. As a whole, the entire bracket is symmetric. Yeah, the hole is definitely off center within that little piece of the bracket. I can see that with the calipers. Okay, I think that's what I want. Let's have another hole on the other side, avoiding all the helpful guides. And then we'll just constrain those. And then I'm going to stick that to this line. And then I want this to be a construction line and horizontal. And I want a similar construction line over here, which I will use. I guess I'll need 2 of those for X and Y. It's like dodging the automatic constraints you don't want while kind of aiming toward the automatic constraints you do. It'd also be easier if these had keyboard shortcuts that I knew about. They don't have anything in the context menu, but that would be really handy. Alright, I think that should be fully constrained now. Well, except for location. I guess where do we want the origin? Where is the origin? The origin eludes me. I think I want this midpoint to be on the origin. Cool. And then I mostly don't care about the rest of this bracket, but let's at least give this a kind of stand-in thickness. And by measuring the part of it that is pretty much uniform. So that's like, 6 millimeters. All right, that's my little fantasy bracket, which is inspired by the actual bracket and will serve as a fitting stand-in. All right, now this design will actually be the camera housing mod, which may be a 3D printed thing or a machined thing, we don't know yet. Anything is possible at Zombocom. Ooh. Okay, and this thing. Okay, so refreshing my memory on what orientation all of this stuff goes in. So that thin piece goes closest to the camera, closest to the lens. The other side of that is the motor body. And actually modeling what we're talking about with the, I guess technically it's this side of the camera, but, you know, basically that idea. It's just, I keep having to, like, reconfirm that this actually fits, because these motors in my head are always bigger than they actually are. This gimbal is really small. So that requires, I don't see any way that's going to work without machining. So not only do I need 2 holes there, I also need a hole for the wiring. And then the less invasive option is to put it kind of over here. I wanted to rotate that first. Let's rotate this first. Fine. Rotate, and then align. I want. That's not the orientation I wanted. I didn't want to align that as a plane. I wanted the edge. Well, I wanted a point, actually. I think the edge works, too. I think that's centered it on the edge. I can measure it to be sure. Let's also... I can do point-to-point moves. Move this component using these 2 points as reference. Now we're starting to see the machining necessary. And let's cut this in half. Where's my axes? There they are. Ooh, look how thin it is. There's my thing. Yeah, so that's the real business end of this project. And in fact, it's worse than that. Is that? Because, I mean, there isn't any room for the screw head like that. So in fact, I would have to put this bracket even further in. So what I'm modeling right now is basically this, which is kind of what I wanted to do. But there's just no room for the screw head, so actually it would have to go in a little more, which you can see I had to move this up because now I'm hitting this out of focus motor housing, which is cylindrical and not cut off like the bracket is. That makes things bad. That, I think, starts to be a non-starter then. So I think maybe that solution is perhaps dead. Once we're back to this. Oh, Wildmania is suggesting that when I machine this to make sure that I'm not punching holes in this that would let light in. That's a good suggestion. This thing was not actually light tight to begin with. Like when I took these holes off for the side brackets, you could actually see LEDs on the circuit board shining out through them. And I think I might be assembling this without the metal back panel, but I'll just 3D print something, and I can use either paint or foil to make it light tight if that's a problem. But yeah, it isn't light tight on its own for sure. So I think that's kind of leading towards something that's more like this. Let's maybe include this screw hole in the model so we can see where those line up. Oh yeah, Kyle suggests using black hot glue to shore up the light tightness. That's a great idea. I've got a bunch of that, and that, I mean, it might not be the lightest option, but it's probably not the heaviest option. I mean, it's certainly going to be lighter than the back panel was. You know, if you strategically place globs of hot glue. All right, let's save this model for now and add the holes to this one. Oh yeah, black hot glue is great. I learned about that trick from Ben Krasnow, who I think he has like some tips and tricks videos with just like random stuff. I also learned about the, actually I think he has a whole thing about hot glue where I learned about the black hot glue, and I can't remember whether it was in that video or he told me about that separately, but he also told me about the, you know, I learned about the thing from him where you can release hot glue really easily with isopropanol. So I use it a lot more now for prototyping, because it's actually pretty easy to take off. I guess I'll use these left and right indicators, because these are still symmetric right now. I'm about to break symmetry. I guess I'll do the sketch on the sides. That's not, I mean, usually I would do it on the perpendicular axes, but in this case I'm going to be measuring it on the side anyway, so I guess that's probably fine. I don't know whether the hole is actually done straight through or on an angle. I don't know if it matters that much, given how small the draft angle is. Yeah, the angle is subtle, but it should be there. was not the one I wanted to project. Project the outside, because that's what I'm going to be measuring this on. I guess I don't need to project that because I'm already sketching on it. It just was playing tricks with my eyes. And this is probably going to be centered. I mean, of course we're going to measure it, but... So this was our... I mean, this is not even a square thing that I'm measuring. So if I try to measure this at the center there, I'm getting 42¼ millimeters. Let's... I guess I need to draw a line here anyway. I mean, this is a construction line, but I'm also just going to use this as a place to save that measurement that might be important later. For just double checking against my other measurements. And then height, I'm measuring in the middle. Pretty much dead on 19½ millimeters. All right, these are very under-constrained right now. And now I'm going to measure these two. I want to point at the intersection here. Why is there no there's no keyboard shortcut for point? I like points. I use points a lot. I like having a single coordinate, or a single coordinate pair that I can attach something to. Oh well. I might as well put the circle here while we're in there. This will also be a clearance hole, so 2½ millimeters again. Let's just make sure that these are M2. Yeah, that is M2. Good old metric threads. 2½ millimeter clearance hole. Okay, now I'm going to measure the legs of these. That looks like 20.9. Oh geez, this looks actually pretty asymmetric. It's like 20.8 on one side and 21¼ on the other side. Maybe they're just not drilling these accurately. 21.4. Well, it looks like it's intended to be in the center, so maybe I'll just put it in the center in the model, but keep in mind that this is maybe not the most accurate feature on this thing. 9¼ there. And 10. Is it 9¼ from anything else interesting? It's roughly 9¼ from where that fillet actually starts. So, all right, well, I'll put something in the model right in the middle, but Milan in chat is suggesting, well, if I have to use the angled location, I could add a spacer and then machine the angle on it to match. That's kind of what we were talking about with this solution, but that still requires drilling the holes in. And I mean, I guess if you attach the spacer and then drilled, but then the spacer would need to be made out of a similar material. Like I couldn't like 3D print a spacer and then use that to help with the drill alignment, I think. Oh yeah, and then there's also the screw head problem, which I think is the real nail in the coffin there. Like even if I do all the machining like that, the screw head doesn't have room, which is like really annoying. All right, well, I'm gonna give up on the good measurements for this side and just put it in the middle. Middle, middle, construction line, and the middle. Great. Fine. It'll be fine. And then cut that out. Same deal on the other side. It's not quite exactly the same because of the, I mean, it's, the two things are slightly angled in like that. I wonder how the 3D print's doing. Still prompting away. That middle part is interesting. It's got kind of two different curves. It's got the kind of U-shaped curve on the outside that the cord actually runs along, but then it's got a like a 45-degree taper on the other side that's mostly for printability and also getting out of the way so that the side on the plastic on the other side of the bearing can have a lot of support behind it. All right, these holes are disappointing. I mean, I think I'm probably going to be using epoxy. Yes, yes. I know the component's out of date. That's why I pushed the button to update it. There we go. Okay, now I've got that hole. Fine. Let's stop doing this section view and try the other plan. I don't know how to exit section analysis mode in Fusion 360. This is something that I've had trouble with multiple times and I have not found a good solution to online. So far, all I know how to do is to basically set a degenerate case such that everything is visible, but I don't know how to actually turn off the section analysis. Now there were like stale flags there left over. Anyway, every program has bugs. Okay, so this time I'm going to remind myself what the orientation is of the actual this metal piece. So that thin piece goes against the camera housing, and optimally, like thinking back to my center of gravity experiment, this should come to basically the same level as the front of the camera housing. So I think I want to move this. Oh, can I select the middle? I think I selected the middle. And I think I want that on the side that actually has the holes. Maybe it's easier to just rotate this. Axis. Do I need to construct an axis here? Maybe that is less easy than just moving this piece. Okay, so that doesn't sit totally flat because of that little draft angle. So I think I need to offset this off by some amount that I can manage. Like, I mean, the trouble with this is if there's going to be material in there, then that material is then very thin and fragile. I also might just design this to not worry about this draft angle, though, because it's just so small that, like, having the camera off axis by that little is really not going to change much. Like, you know, it's like if you're flying a quadcopter, you're dealing with a stick that is, you know, you've got to mentally rotate that to the vehicle's frame of reference. And so there's going to be a similar issue here with any misalignment between the gimbal's coordinate system and the camera's coordinate system. But for this tiny draft angle, I'm not going to worry about it. So for that, I think I want to use, well, I think I want to do this in a couple steps. I think first I want to move these a little further away so I just have working space. And then I want to make sure that these are coplanar by aligning this plane to this plane. And now that also took care of rotating it that very slight amount that it's going to be rotated. And then, oh, cat found the digit keep packing. You too, go. We're around. Yeah? Purr. You're such a purr tiger. He really likes that stuff. Meow. Good little creature. Okay. Oh, okay. Chris to the rescue in the chat. You can hide or delete the cross-section under the analysis tree folder. That's cool. Okay, analysis tree. Oh! I didn't know this existed, so I can actually store multiple section analyses. That would be useful in my other project. Yeah, I didn't realize that was like an actual object that it created. That explains it. I figured that it was like some state, like there was a global state of, like, am I slicing what I'm showing or not? I didn't realize that it was part of a grander system there. Yeah, the section analysis comes in super handy for this part. Open little thing. Turn off the DSLR to free up some more screen space. So yeah, this is my assemblage of parts so far. These mounts are pretty temporary, but the red parts in the middle are the ones that are printing right now, and they're a little bit less temporary than the others. So then add a construction plane here. Oh yeah, so here's all my old section analyses that okay, I didn't know these were stacking up here. Cool. Now I feel dumb for not noticing this before. So many different kinds of objects in this program. So, this one. Yeah! Ooh, that's fun. So now I can turn that on and off. Yay! So, here's the pieces so far. This, what are we looking at? This color difference is really subtle. There's actually a theme there. How do I assign less subtle colors, I wonder? Well, anyway, these are two different plastic pieces that will be glued together. I guess I just have to leave it alone so it draws the outlines. Yeah, this bottom piece is one that I already printed. It's right here. So yeah, it's got room for the bearing here in the middle, room for the M6 bolt to poke through a little bit, and then this angled interface is where the pieces actually super glue together. But yeah, okay, that made my day, having the ability to actually manage these section views that I create. It's nice. Put that sensor away before I scratch it. Okay, back to the problem at hand. Camera housing mod. Let's save that, why not? Okay, now I'm doing a point-to-point move. Hanging out with these midpoints again. Okay, that's the move I wanted, I think. And should I move it any further, or is this a good position? I hear you, Chico. So that position that I have in CAD does, excuse me, that does leave some of these screws obscured a little bit. Let's measure how far to move it to keep the screw heads all accessible. Caliper Town, where are you? There you are. Yeah, I guess it would be handy to have the screw heads in that CAD model. Oh well. But this is easy to measure. Yeah, actually, I say this is easy to measure as I struggle to hold everything. Do as I say, not what you witness me doing right this very moment. $14 millimeters. 15 to have a little more margin. Okay. So that thing that I just measured was, yes, capture position. Let's make a horizontal line, and then let's make a vertical line, and then let's dance. Yeah, so 15. That's the measurement, and then oh no, I don't want that. I think I can just use that to move this component now. Can I do point to point for that? Because I don't really have a point. I have this line. Oh, maybe I'll project that onto the sketch. Fine. I'll actually do the stuff in the sketch like I probably should. Am I in sketch mode? I don't think I'm in sketch mode. There we go. So I want this thing, and sure, let's have that thing too. And then, again, I want a point, and there's no hotkey for it. Whoa, let's not go inside the geometry. Oh, that line doesn't quite intersect. Well, now I have a point. Answer solved. Oops. Not that. Move. Okay, camera. Oh, this is upside down, isn't it? Yeah, I measured that on the sketch upside down. Let's just delete this and start over. That was 15 from the other side. All right, I think that's the points I need. Move that to there now. Oh, I didn't actually put a point there. Point. Okay, is that right? Just finding the geometry of this project way less intuitive than most things. I think that's the right place for that. Oh, no. No, I had that right the first time. Okay, fine. Yeah, no, I was getting confused about which side of that mount the wire has to come out, but it should want to come out the back, and that does matter because there are stops in the motor housing, so it can't rotate all the way around. Fine. Fine, fine. Okay, yeah, so this is super unintuitive because of all the pieces that we aren't seeing right now. But this is, if I maybe bring the camera back. So if I match the view that we have right now, and all these pieces are black aluminum. So there's the camera housing, and the motor wants to be actually substantially to the front in the camera housing because of where the lens is going to be. So we've got this, which is still blurry. Okay. So yeah, that U-shaped channel there that you're seeing is actually where the circuit board with the wire is going to kind of poke, or the connector is going to poke out. Then there is the space for the L bracket that we've been talking about. I think that's the most viable solution currently because the other bracket would work, but it would add some space there, which we'd like to avoid. And this I like, but then the screw heads have nowhere to be. So here, the screw heads have enough room, and I mean, this piece needs to be somewhat creative, but as I'm saying, the screw heads have enough room. Now I'm wanting to confirm that. Oh, here's my screw. But yeah, they have enough room by like an entire ½ millimeter or something. It's not a ton. I should maybe put those screws in the design, since I can just import those easily. Yeah, let's do that. Let's import some screws. Oh, and yeah, a good question from Wildmania in chat. Why an L bracket? Why not a square piece with the proper dimensions? It totally could be a square piece. I think I was just saying L because that's like the minimum shape that it needs, but yeah, if this is 3D printed, then a little square block where I could put, like, I'm liking the idea of not having to drill on a slope here if I can avoid it. But the side draft angle is not too bad. So I could use this hole, or I could add a couple more, then make a plastic block here where there's, these two screws kind of coming in this way, then maybe screws going in right there and right there perhaps, and then a channel open here for the wires. So then, and then the wires kind of will just loop around back and then go to the circuit board. I don't think I need to worry about cutting a hole through here for the wires. So yeah, that's kind of nice. And yeah, drilling more holes is probably fine. If we're going to do that, I might do the drilling, like I assume this is going to involve 3D printing a plastic piece and doing the drilling, and I can just do those two things simultaneously after I have the CAD model. So let's actually probably pick some longish screws for this. In fact, well, so the screws on the side of the camera can be just arbitrarily long. I can use nuts for those even. Like, I don't think I have M2 taps, so it'll be easier just to drill through and then have a nut on the other side. I don't even know if I have M2 nuts. I might have to use M3 screws, because I have a lot more of that. But yeah, a pair of M3 screws should be fine. I can just cut some big ol' holes on the drill press. Yeah, I think that's pretty good. So maybe I assume I ignore the middle hole or use it for like a wire, and I just use the drill press to put some holes in for M3 screws. And then I can also make the holes themselves a little oversized so that I can have some room to adjust a little bit, then tighten down the screws, and then maybe also epoxy. Yeah, I'm liking that. And then I can keep that middle space clear for the wires. So in that case, I want M3 screws, which can be kind of arbitrarily big. And then the M2s, I guess I need to know how deep can they go into this. Oh, this is also threaded all the way through. So I think the screws can go all the way through this block that I've already modeled. So that's handy. And that block is M2 threaded. Yay! Where's the cat? Oh man, he's way over there. You coming back over here too? Orbiting the camera. See, once we have a flying camera, he won't be able to orbit it quite so easily. Okay, so in that case, how thick is this? I think this was like 6 millimeters. Yeah, 6 millimeters. So maybe like an, what do I have? M2 by 10 maybe is the longest I have in M2. I don't want to make it too long, but that might help. M2 by 8s are also pretty nice. But let's assume it's M2 by 10 maybe. Yeah, I have M2 by 10 button head in enough for this project. Let's just get some models for that. Oh, that's not what I wanted. No, I was just there. There we go. Rounded. M2 by 10. Yep, this little thing. I think we're done with that picture-in-picture. Alright, so we'll need a couple of these. First one. That could certainly stand to be longer, but I think that'll do just fine. I mean, it won't quite be just like a block, but it'll be a roughly block-shaped piece of plastic, which I'll try to make kind of minimal. How did this turn into a 3D printing project? I guess I have to make a copy separately. Oh, I can do it this way. The angles are the same, I just need the offset. Alright, and those don't have to go in that far, but they certainly could. Maybe they shouldn't go in that far. Let's leave, because I want them to have a little bit of room to tighten into the holes, so maybe I will move them out a little bit. I think I need... This is so annoying when things aren't quite axis aligned. Can I move a particular amount along a thing? I don't know. I might need to make a little line to be a prototype for the move. Ah, this is annoying. Okay, maybe I just want this to be lined up with my axes. Can I just do that to everything? I don't know if I can easily. Align everything. Because the thing is, I can't align stuff that isn't a component or a body. So moving these screws still seems like the easiest way to do this. Maybe I need... I guess I could just make a sketch on this plane. And all I want is like something that has the right angle. So yeah, sure, 2 millimeters, 90 degrees. Both the screws. Oh geez, where is that tiny line? It also draws stuff that it doesn't think I will need in the lightest of all alpha blending. Okay, that's better. Now, anything else I'm trying to avoid here? So let's also make something to placehold for the wires. For that, it's another rectangle thing, and I want that to be on the midpoint. Oh, this is actually one of the cases where I have 2 lines and I want their midpoints to be the same. Imagine that. Okay, now I've got this thing. This, I don't even know if I want this to be the full, because like this cutout is actually really big, and for structural reasons maybe I want it to be less big in my 3D printed part. I mean, 8 millimeters, sure. Let's make it 8 by 4 millimeters. This is a round number that is somewhat lower than the actual space available. And should be plenty for the wiring. All right. So we'll need that in a bit. So now I've got like gimbal lock happening with my space mouse. Why? Oh, there we go. I feel like I lost an axis. I don't quite know how to explain what's going on with my mouse, but it's not correct. To unplug it and plug it back in and see if that helps, but I suspect it might be the Autodesk side that I need to restart. Let's restart this program briefly. Where is Tuco? Hey kitty, where are you? Oh, there you are. Hey Tuco. You don't want to be picked up, you want to be free. What you asking, Tuke? Hey, buddy. Burrow. Burrow. Oh, well, I think, where were we? Oh, geez, that was a ruler falling on the ground. Okay, totally just lost my train of thought. I don't know why this closed. Was Tuco, did I do something stupid with the keyboard? Anyway, we're back. Anyway, we have that cut out. I think all this is missing is the spot for my M3 hardware. So the M3 hardware, let's make another plane. This was like my lower keep out. Let's have an upper keep out region. By offsetting that. And this is just going to be roughly like how thick is most of the stuff on the circuit board in the locations roughly where we're going to care. I'm not even going to take it out of the bag to measure this, but like the amount of clearance I feel like leaving there is maybe 6 or 7 millimeters. Let's see what that looks like. That is 7 millimeters. And that seems fine. We could drill some, we could have plenty of room for M3s over there without getting in anybody's way on the circuit board side. Oh, Tuco wants to go outside. Oh, I'm getting hungry. It is later than it feels for some reason. Alright, well, circles? Circles, anyone? For M3 clearance, let's make these like a whole, well, actually, I would be drilling this using my non-metric drills. So what is that in English units? Like an 1/8 of an inch drill maybe would be Tuco. Tuco, it's too late to go outside, honey. Let's see which of these gives me a generous clearance hole for an M3. Hey Tuco, you're really vocalizing a lot. Oh, Tuco's starting to wear down my patience. An 1/8 inch would be a clearance hole, but not a generous clearance hole. Looks like 9/64s would be enough to be kind of generous, but still at no risk of... I mean, I'm not going to be worried about the screw head slipping through this part anyway because it's going to have plastic in front of it, but it would still be nice to size it such that the screw is significantly not going to go through the hole. So let's start with the 9/64s, since that's a drill that I actually own. Nine divided by 64 inches, whatever that even means. How do I inches in this program? Okay, well, times 25.4. Oh, Tuco. Tuco, it's too late to go outside, dude. So then these can go pretty much anywhere here that it's convenient. That would not be so convenient because wires, but it wouldn't be terrible. But I think we basically want it to go like there. Maybe not quite so wide, maybe like there-ish. Make another of these, make them identical. Put a line between them. That midpoint is so invisible. Where are you, little midpoint? There you are. Tuco. It's not gonna work, honey. It's too late. Tomorrow's another day. Oh, okay. Now we got some symmetry happening. I think I'm just going to pick some measurements that seem about right and make everything else fit accordingly. Sure, 32 millimeters for this. I mean, I don't want to make mounting the hardware on the inside of this a problem, but I don't think that's going to be an issue. Well, all right, 30 millimeters. That seems nice. And this one, maybe an even 6. Okay. Let's insert some hardware here. Oh, cool. US Water Rockets confirms with the wisdom that 3.5 millimeter clearance for M3s are awesome, and the 9/64 is a little bit bigger than that at 3.572. I don't think this is too close to the PCB. So these planes aren't actually the PCB. These are like keep out zones that are like where I want to keep clear. I guess it wouldn't hurt to move it a little further from the PCB though. I don't want to make, like the further I make this out from here, the more stress I'm putting on this bracket, but I can also super glue, I mean not super glue, but epoxy there to reinforce, so yeah. I think that's a good call. I'll make that a little further, or further from the PCB. Four millimeters? Ooh, that's not too much. 5. That looks nice. This is a pretty burly piece of metal too, so yeah. I'm liking this so far. As my cat yelps. Hey, poor little cat. He just wants something he can't have right now. Hey, Tuco. What did that fail at? Oh, I can't have these cut. That's interesting. I hear you, Tuco. Tuke. What do you want? You're such a yelpy fuzz tiger. Oh, cat. Well, I don't really care that much about actually being able to cut this. I think it's just one of those things where the modularity of this design would have to be different for that to actually work. So that's fine. I'm not gonna worry too much. Oh, that's... US Water Rockets mentions that I should be careful that the screws don't interfere with the corner standoffs. That's a really good point. I don't think I'm planning on attaching the longer standoffs, so... but yeah, it would, I mean, it'd be nice if I didn't have to not attach them, you know? So yeah, maybe, how much room do we need to leave for that? Because I don't need those standoffs, but I also don't necessarily have M2 screws that are small enough. I think it'd be easy to just cut a screw to make one a little bit smaller, but it might also be easy just to leave room. Let's add a keep out-ish of like 5 millimeters on the inside. Let's project that from or onto the sketch. So I want another line. Okay, so that's the region where the standoffs are going to be hanging out. It would be nice not to disturb them. You know, maybe I should be thinking about having... really nice not to have these interfere, you know. I mean, these could go in the middle. I don't need that much room for the wires. That's the worst. Tuco, what was that? Oh, the dustpan. I mean, that might be fine. Makes the bracket smaller. I don't like having those super close together, but I mean, these are M3 bolts. They're still 10 millimeters apart. I think that's probably fine. Yeah, Tuco, do you have any bolts handy? Or maybe you want food. What do you want, little guy? Oh, look at that. You had some food over here, but it's covered in ants. That's terrible. Want one of these? Chico had a legitimate grievance. I was like, I didn't think he was complaining about food because I put some food out there that he didn't seem to be touching, but it was like old and covered in ants, which is a problem that he's had before with food. Like, I didn't notice any ants in the kitchen, and then like, apparently they're really into cat food, like more than anything I eat. So, oh well. I think the cat's happy for the moment. All right, well, I think I'm kind of happy with this layout. I'm not super thrilled about the screws being that close together. That sounded like an Android phone booting. Huh. Oh, yeah, there's a phone over there. I don't know why it would be rebooting now, though. Maybe it just updated. That's weird. Anyway, distractions. I think I can make this a little bit wider without interfering with being able to shove a hex key in here. So I'm going to do that just to give myself a little peace of mind, but I don't need to be fussing with this too much. But, aw. Wild Mania is saying goodbye for the night, but they're mentioning this is the best stream so far, which I find that touching. So thank you so much, and thanks for tuning in. 12 millimeters. Ooh, 12 millimeters is nice. Maybe, can I go to 13 millimeters? I think I can do 13. Okay, I'm actually more happy with that bracket. The little things, right? Okay. So, I think maybe actually while I'm still on that sketch, I just want to draw out the outline of the bracket, because I think we're at that point now too. So, we just want to project this and draw around it, basically. That 5 millimeters I drew is actually not a bad place for the end of this bracket. Actually, what is this distance? It is 11.2 millimeters. Maybe I should just draw like a 10 millimeter line from here. Oh, 10 millimeters is huge. Wait, where did I get 11 earlier? Was that measuring from the center? No? Oh, I was just reading the wrong thing. That was the length of the selection. The distance was 3.2 millimeters. That's better. Okay, so maybe let's see what 4 millimeters looks like. I like 4 millimeters. Let's have another identical line over here. Oh, Tuco, are you in a better mood now that you've had some salmon that is not covered in ants? The best way to serve salmon, as far as I'm concerned. I don't know much about salmon, but what I do know about salmon, I've learned from my cat. Oh, have I made an axis yet? I don't think I've like an axis of symmetry in this yet. This might end up being done with the printing just in time to print the next thing. Symmetry constraint. Did that not work? Point, axis. Symmetry. Failed to solve. Why? Maybe I should just have some lines that I can set equal. I just don't want to set the larger line equal to the smaller line. I want the two smaller lines equal to each other. I think that's right. Okay. Let's give adequate clearance to this whole thing. Oh, yikes. That's not supposed to move like that. And that's not supposed to be disconnected. Well, now they're connected. But that needs a vertical constraint. Okay. Still needs some symmetry. Can we use our shiny symmetry constraint now? Yeah, it seemed to work. Yay. pretty much like that. Round it a little bit later after I extrude pieces of this out. Whoa. That should have been a construction line. Okay. Oh, let's also have some slightly less big clearance holes on this side, because the screws will bite into the plastic a little bit. I don't want to make this like super wobbly. So these I still want to keep in mind for making a drilling, for like drilling the other piece, but for actually doing the 3D printing, I think I want these to be more like 3.1 or so. Maybe even just 3.0. I mean, that'll be a tight fit, but tight is kind of what I want right now. And I can always ream them out a little bit with a drill bit if I need to. Do I have any constraints on how far that way it goes? Yeah. Only slightly, but yeah, it should basically just be the same thickness as that piece, I think. Just getting more geometry for reference so I can cut holes. Oh geez, did I do that gimbal lock thing again? Yeah, and this is upside down now. That's annoying. Why? This is like a bug that I don't even quite know how to describe at the moment. Like that is completely the wrong axis. Yeah, it's like it just collapsed two of the Space Mouse axes down onto the same axis. That's really annoying. But I was almost done with this. Man, I'm gonna have to restart this again. I just cannot steer at all. And like I could switch to the mouse, but then I have to relearn all the muscle memory yet again. Oh, nice, Ryan. I mean, not nice, but like it's nice to not be the only one that hits this bug. Ryan in chat mentions that this happens to them too. But they've had luck with unplugging the space mouse, so I might try that again next time. Did it not generate a thumbnail for this one? Okay, I've got my axes back again. Okay, we were so close to done with this. So we were looking at this sketch, and I think I just, oh geez, it just happened again. So it's something about that sketch. Why? Oh, did that fix it? I selected go home from the camera menu, and that seemed to have fixed it. Let's see if that keeps up. Maybe it's some bug with going into like sketch, like when the sketch tries to put you in ortho mode. Hey, Tuco. I guess I should bring the cat camera back over here. Tuco, what do you think about beer? Is it beer o'clock? It is like way past beer o'clock, and I don't have beer. Weird. At least I have sketches that work. I just need to do some basic extrusions. Can I cut? That'll be a start. Oh, I don't want to cut through the screw. I think that's... This is not showing me the body that I actually want to cut. Oh, maybe it is. Okay, I guess that's what I want. I don't know why I'm seeing only one of the screws in here. It's weird, but alright. Let's make room for the rest of that screw. So here we have those two. Let's get a model of the M3 screw we want to use in here, because I also want to make a cutout for the screw head and see how this is all going to, because this might be a problem. We might need a little more clearance there, but that'll be easy to change. Oh yeah. I guess the home icon hides itself. There's so much, I guess I can understand the effort to reduce visible clutter and like hide stuff that you aren't using, but this also definitely seems to end up making stuff that making it hard to intentionally find stuff unless you know exactly which pixel to click on. Oh, what does my stock of not gigantic headed M3 screws look like? Because most of my M3s have these big cap heads. I guess that isn't a problem here. Just imagine that using up a lot of the thickness of my bracket there. Low profile screw heads would actually be better for this. Let's see what I've got. Oh. I've actually got plenty of small M3x8s. Oh, these will be perfect. Little panhead M3x8. I think these are even stainless, which is overkill, but it'll be fine. I don't want socket head anymore. I want... Can I reset this? M3 by 8. I think the one I actually have is stainless. Why not? Let's use this model. Let's get a nut for that. All right, great. I'll do some alignment. That wasn't what I wanted, but I also think I need a sketch to align that to first. I always forget where move is. It's weird to me that move is under modify, because it doesn't actually really modify anything. Actually, here I want align. This would be easier if these circles on the nut weren't broken. Will that still give me the center? That probably would have worked if I didn't pick the point, but the circle. Yeah, that's what I wanted. This sure makes an M3 nut look enormous. Like, I'm not used to M3s looking this huge. Where did that other... Oh, I just hit it. That's fine. So let's make... let's just make a copy of that. Oh, I'm in a sketch. That would be a reason for it to be giving me sketch tools. It's also bothering me that this nut is pointy side down, but it's fine. They need to be able to rotate. That did not do what I wanted. I thought that was the copy I wanted. Let's try that again. Modify. Oh, I see. I had not selected the component. It was trying to copy the body, and that wasn't working. Yay. Oh wait, do I have 3 of them now? Ah, why do I didn't want 3 of them. Oh, that's fine. I'll just... What is that? That is a body. Where did that come from? I must have accidentally made this while I was using the move command before. Where did that come from, though, in terms of the timeline? Oh, well. I'll just hide that for now and figure that out later if I care. Right now, I just want to put the screw in place and make this bracket. Oops. That's not what I wanted either. Okay, well, we actually want these probably flush with the top surface. So let's do a second alignment. There we go. That's what we want, I think. So let's make another copy of that and then give them a place to hang out in the bracket. I think we're going to see those interfere, and I'm going to have to change the distance between these bolts a little bit. There's some good suggestions in chat. Using nylock nuts, which is probably a good idea. I don't know if I have like a lot of nylock M3s, but that would probably be helpful for this. And giving the components names, yeah. I definitely, like in the complicated part of this, I've been giving things useful names, but this project still feels like I just want to quickly design something and then 3D print it. These names are kind of useful. I think these are the master car part numbers, but they certainly get monotonous after a while. Ah, I clicked that by accident. It's not what I wanted to click. All right, modify, copy. Also did not seem to do what I wanted. Or was I just... what is going on? Okay, create copy. I've got that one component selected. Then I need to hide some of this stuff so that I can just see the points that I'm dealing with. Oh, I guess it copies the hide setting from the thing I'm copying. Maybe. Well, either way, that seems to have done what I wanted. Okay, and... oh, geez, that is some messy geometry on that sketch. Just wanted to project the circular parts of the screw and not the entire thread system. What? I think I'm not selecting the sketch version of that. I'm selecting it on the body. Oh, and this plane is so in the way. Where is this even coming from? No. Why? Let's see if that does what I want. There we go. That is the gap we want to avoid. So it was later than this. $11. Let's try 11. Ooh, are those not properly linked? Why did that not automatically update? Okay. Well, maybe if I move these objects over. This would be so much less annoying if this stuff was all axis lined and not on a tiny, tiny slope. Can I get any of these center points? I really like a center point. Oh, all I wanted was a center point. Is that 2 millimeters? No, that was not 2 millimeters. Oh, US Water Rockets is suggesting the selection filters under here. Yeah, I should remember to use these. Mostly, I'm just not quite used to how these filters work, and so I just always end up reaching for a different tool instead of these. I kind of miss the way filters work in Rhino, but they're probably not that different. Oh, right now I'm just having coordinate system problems. Like I want to move this over, I just don't have the right reference points to make that happen. I think I need, well, I think this would be easier if I projected some of this onto the top, because I have these like circles on the top that might be easier to work with. I just feel like this project is a huge mess. Like I probably would have started over and redone this if I wasn't on a stream. Maybe that's the lack of sandwich speaking. Okay. Is that what I needed? I was selecting a range of these, not just one of them. No. I just really hate the way selections work in this program. I'm sure I'll get the hang of it eventually, but right now it's frustrating me so much. I want to select this component and move it, but move is not letting me. Oh, because I'm in sketch mode. How did I get in sketch mode? Alright, now I have point-to-point move from the center of that to the center of that. Okay. I probably wanted that to capture position, didn't I? Because now this... Can I move these two after what I just did? Not really. That's fine. See, I still just don't understand how moves work as far as existing in the timeline. Because now I've got this thing that happened, and I think I just need to roll back these two features. Delete that. Delete that. Like, this is super nice when you get all the features linked together such that you can change something early in the history and it propagates through, but I've not gotten used to debugging it when that goes wrong. And part of why I wasn't worrying too much about the exact spacing before was I figured it'd be easy to change. Here I am discovering why it doesn't always work out that way. But I don't know, these are always excuses to learn the tool better. Okay, now I need to cut those out again. Cut these out. We actually maybe investigate this a little closer to see if these will fit. I think that's still going to need more clearance. I mean, and the thing that I just did, like, is that going to be linked into the history at all? Let's find out. Let's try to go back and find that sketch that actually matters. Is this the one? Yeah. No, still doesn't want to... Okay, well, before I move those around too much, let's make the holes for these screws, because I at least want to make sure that they have enough room. Okay, so I selected filters. I want to turn all these off. Oh, man. And then the gimbal lock thing. Okay, clicking the home definitely fixes the Space Mouse gimbal lock issue. That's good to know. No, not that one. Which sketch is that? I just want this one. Okay. Now I got room for some screw heads going that direction. That is kind of thick. And yeah. Those have to be pretty close together unless I put them way over here, in which case they'll just be in the way of that standoff thing. And I mean, that isn't a deal breaker. Like the standoffs, I can take them off, but having these nuts interfering with that will make it harder to access those screws. So having two closely spaced M3s is probably better than the alternative. So where was that sketch again? I should actually give this one a good name. Really don't feel like giving this a good name. 8 millimeters? Oh, that's gotta be enough room. Yeah. At least these are easier to move now because I've got this sketch on the top. That's definitely easier than trying to fuss with the side of the screw that has the threads. Okay, and then same deal here. Just sketch on this face. Project those two circles. Clean that up before I can make progress. Yay. Is that our part? Oh, we still need a place for the wiring, which is going to be really tight here. But not impossible. Where's that sketch we've been ignoring with the wiring on it? This one? Yeah, that's not as much room as I'm going to have. I mean, I could take the wires out a different side too. How much room do I actually need for the wiring? It's basically the same constraint as this opening in the magnet that I have to pass wires through, which in this case is about a 3.5 millimeter diameter hole. I think, how does that compare to this? What sketch is that on? Sketch 5? did that just snap to? Oh, is that a grid snap? Okay, that's interesting, but not what I want. What is this thing? That is a construction plane on that component. Great. If I move that down a bit, that might work. And also maybe make it triangular or something instead of a circle. Not that sketch. Every time I enter particular sketches, it just messes up the space mouse, and I have to redo the camera. Okay, so we want something with roughly this area. Actually, can we just specifically avoid the screws? They're not on this sketch yet. So maybe we should just make a later sketch. Okay, fine, let's make yet another sketch over here. Fix the camera. And what does this look like without that? Something kind of like that, but like actually drawn more accurately. It's like 2x4 millimeters. Seems plausible. Okay, well, maybe in that case, I can use the original sketch since it was just a rectangle. Let's get rid of this. Really, I think 2 is the midpoint, or oh, maybe this is right. It is a lot smaller. But that fits. 2x4 millimeters. Yeah, that seems like it'll work. Yeah. Well, let's at least give the wires a rounder edge to scrape against. Not that they'll be moving really, but. Making that too extreme could make it harder to print, but that should be fine. Alright, maybe a little bit on these corners too while we're filleting. I don't know if that'll even matter once we print, but okay. Well, this might be a first stab at this piece. So if we take out, well, so here's the camera, lens is pointing toward me. Let's go back to perspective mode. Okay, so lens toward me, and the motor, which I still haven't modeled, be roughly over here. Wires pointing that way. The rest of the gimbal kind of going off this way and then up and around. So then this bolts on here, two M3x8s, then a couple of M2x8s going through here, and barely enough room for the wires. And oh, let's also make these edges not so sharp. More like that, and then this is going to be up against, actually what is that up against? This is actually not, this is going to be kind of an external corner also, so we can, might as well smooth that. Make that one a little wider. Okay, is that it? So if we take off these other components, so take off the camera, take off the gimbal mount, then we've got this hardware. I also don't know how to put components into a group. I'd love to have a group that's like, here's all the M3 hardware, here's all the M2 hardware, but I don't, from what I've seen, like, I create a group here, I don't think that like makes them easier to deal with in the browser at least. So I don't know. I don't know if that's not working or if their definition of a group just isn't as useful as what I would expect a group to be. All right. And that's imminently 3D printable and small enough that I might as well just do it with as much infill as I can stand. So is the printer free yet? It is, great. Maybe let's get this started printing. It might be a little late to do drill press stuff right now, because it's like a little after midnight here. But maybe that'll be the next stream, is putting the camera on the drill press and making the modifications necessary to get M3 holes in there. It'd be nice to test fit this piece on the gimbal at least. Let's get this 3D printing. So for that, let's give this a name actually. That's our bracket. I haven't set this up to go directly to the 3D print program, but I really should. Curva. Is that the right version of Cura? I always have two versions of Cura installed because I've got like the standard Cura and then the Type A machines modified Cura. Oh, maybe I only have the Type A Cura installed on this machine. That's not what I wanted. That's right. This worked. This worked in macOS because it was in an app bundle, but I think here, Cura is being started up by something else. What is it actually running in? Where's properties? I liked it when there was a properties right there. Yeah, so this is running Python W on the Cura module, which is probably not something this can handle. So that's fine. Let's just save this as a file. Oh, I'm sorry I didn't have that on the screen I mean, not like anything especially interesting was happening. I was just fussing with the export, trying to get it to send the file directly to Cura, and then it was failing at that. Cool. I don't know if I have any material that would be like significantly better than just PLA for this. I mean, I could print it in like T-glass is pretty small. I've got T-glass, or strong, not small. So T-glass, not because we need it to be clear, but just because that's pretty strong, and I have some handy. High strength, no adhesion. I don't think we'll need to brim or anything. No supports. Whoa. What happened there? Is it not laying... Oh! Yeah, it wasn't laying flat because it was on that crazy coordinate system that we've been doing all the design on. Sometimes I have to push lay flat a couple of times for it to actually converge on a stable solution. Okay, so now we've got this. Wire channel. It's looking printable. Maybe let's use a smaller layer height too, since this is such a small model. That might help with the screw features and everything. It's still only supposed to be a 30-minute print, if this is to be believed. Let me also send it here. I'm gonna have to go in there and put different material in the printer. Oh, Tuco's got a new hangout. This has been a long stream. Let's see how the printer's doing. View gimbal. I think I still have the clock not set right on here, so the sorting things by date doesn't actually work. And uploading directly from Cura to the printer sometimes works, but it's pretty unreliable. Okay. Let's get this printer started. That should be a quick little print. Probably still out of the scope of this stream, but we do have this piece, which I can do a little bit of post-print cleanup on. Just take off the brim. This is still my favorite print cleanup tool. It's just a little bit of spring steel with a silicone handle. It's not that sharp, but it's sharp enough to take off most of the plastic debris. Do I have a sanding? Yeah. This is totally optional, I just don't want it to have rough edges. And it just has, that brim material is just something I usually use to keep the edges from curling up on my non-heated print bed. 2 pieces of the spool. Oh, that's not bad. Might require a little bit of sanding and clamping to get that to glue tightly without a seam, but that's basically what we're going for. Yeah, it doesn't quite fit perfectly, but I think with a little bit of sanding it will. That is actually pretty tight, even without the glue. And then this side has room for a bearing, and the other side has room for the motor mount. Some extreme perspective on that cat. Yeah, I don't always print with a brim, but I usually do. It helps, like most of the time when I have problems with a failed print, it's because of warping, something peels up on the edges, which you can have that problem even with a heated bed, but it's a lot easier to have that problem on a non-heated bed. I have a warmed bed on my 3D printer. You can't quite see it in the camera right now, but I basically put one of these foot warmer mats, like the same one that I use here on the desk, under the print bed. And it's not much heat, but it does seem to help for PLA at least. The downside is it warms up pretty slowly, so I usually just have to leave it on most of the time, unless I'm not going to be printing for a while. From earlier, just kind of forcing it together, you can already see the high spots have kind of a rubbing pattern on them. It's mostly places where it isn't quite circular due to the belt drive on the 3D printer, which is a good sign. I mean, not that the 3D printer being imperfect is a good sign, but it's a good sign that that's the kind of inaccuracy, I guess, rather than just like boogers or a design flaw. Oh yeah, the US Water Rockets also says the brim is a good way to prime the nozzle, which I also agree. Also, they say my filament comes with spools just like that. And the irony is not lost on me. I was thinking like, oh, could I design WinchBot to use 3D printer filament spools? Because I have a bunch of those around here still. I think the main problem is that the diameter isn't quite what I want, but it seems like it might work out. It's not quite. It needs a little more sanding still. Yeah, reaming out these interior curves with this tool is a lot easier than trying to deal with this edge here. Tuco's doing his part. Oh yeah, I guess the question in chat, which I didn't really properly see, was how do you know when to use a brim? And for that, I usually use a brim. The reasons when I wouldn't use a brim is usually if I care a lot about, like if I'm printing something where, what's a good example? Like the first layer is kind of special because like that's your one opportunity to have stuff in a totally arbitrary pattern that's supported, no matter where it is. So a lot of the time I'll want designs where, maybe there are two pieces that are connected by like a plastic spring that you're printing, and just noticing on the monitor, I can't quite tell whether the piece is like sliding around. I might have to take a look at it in person. But so if you're like printing two things with like a squiggly spring in between them, you want that to be free moving. You don't want to have to like clean brim pieces off of all those little tiny squiggles. Whereas something like this, if it didn't have a brim, then the edge would just tend to kind of curl up as it prints. So it's kind of a trade-off between like the brim gives you more post-processing and can interfere with more delicate designs sometimes, but it's usually really a good insurance policy against your print just failing. Oh, that is really close. That needs a tiny bit more sanding, but it's close. I'm going to look at this. I want to see how it's doing in person. Oh, it's fine. So I didn't use a brim on this, mostly because it's just so small that, well, it's both so small and has a shape that's not really prone to curling up, that I figured I could get away without it, and then it would save me some cleanup. But it might have been a silly decision. It might have been safer to use a brim. Oh, US Water Rockets in chat asks, does Tuco's tongue feel like sandpaper? Our cats was like that. Yeah, definitely. I mean, it's rough. I don't know if sandpaper is quite how I would describe it, because maybe at first it feels like sandpaper, but actually I think it feels more like Velcro, like the stiff kind of Velcro, not the soft kind of Velcro. And it because it has this, like, it doesn't feel gravelly like sandpaper. It feels like, kind of prickly. And so I think that's how it works. I think their tongues are kind of like little combs for combing the fur. And his definitely seems to do that pretty well. I'm gonna cut my thumb off trying to do this. I like thumbs. I mean, I'm glad Tuco has thumbs. He gets to participate in the joy of having thumbs. And I think what might have made this a little easier is if I intentionally designed it to have a bit of a gap, like just a smidgen of a gap, but then had it actually close together like just at the outer edge, so that, at a small scale, that very outer edge, kind of came to a knife point. And in 3D printing, that maybe means it has like one extra layer that the inner layers don't. But that might have helped this fit a little easier. As it is, it just means I have to do some sanding. But since I am making 4 of these, it may pay to optimize the design to have as little post-processing as possible. But I don't even know if this is going to be the final design. So my plan for this piece is to do some mechanical tests to see if this combination of motor and spool diameter and all that is going to work out. actually this might be a problem. This is like one of those cases, it would have been really handy to have an extra 1/10 of a millimeter, maybe 2/10 of a millimeter in the design. I try not to keep all the tolerances super crazy tight like that, especially with 3D printing. I think this was one of those places where I didn't really know how much it would matter, and I figured I could deal with it no matter what, and if it was a problem, I could pay more attention next time. So, kind of a triage of design. Like, you can't pay infinite attention to all the design problems all the time, so you've got to just pick some stuff to pay attention to, and this was outside of what I was paying attention to on this particular iteration. It's still a little not amazing, but maybe I'll do a little sanding, and before wrapping up this stream I'll at least be able to clamp this and glue it together, because it is going to need some clamping. And maybe having room for the bearing would be a good idea, because I feel like clearing out room for the bearing is going to be much harder once I glue the other piece on. Bearings. These are all just 606 skate bearings. Oh yeah, that's going to be a tight fit too. Didn't really give this any clearance. I wanted it to be a tight fit. Well, maybe I press this in with the vise before gluing the two halves together. It's also just the kind of fit that does not tolerate any angular misalignment. Yeah, I should stop designing this stuff so tight when I get my vise. Oh. The vise was next to me all along, like the spirit of Christmas, or whatever else people lose but don't actually end up needing. But I'll need this vise. That's going to be a problem, isn't it? Yeah, okay, vise is actually not going to help at all on second thought. This will not fit in the vise straws. I could hammer, but I don't think I want to do that given that it's so late here. Let's just use our old friend. Oh, there's a little discussion in chat about my cat Tuco's name, and as someone else already mentioned, Tuco was named after one of the previous caretakers that had Tuco before me. Named Tuco after the character from Breaking Bad, and I thought it was funny and completely unlike his actual personality. And then Ronald in chat says, was Tuco also on Better Call Saul? And I've been meaning to watch that. I think I've seen like part of it, but certainly not the whole thing. Oh. Yeah, US Water Rocket says that if my printer tends to make the tolerances tight like this, then the thing I'm printing might have some similar problems. That might be very true. But with that one, I'm perfectly happy to just run a drill bit through it if I need the holes to be a little cleaner. This I'm a little more fussing about the design in addition to this particular object, because I'm going to need to make a bunch of them. I think part of it is that, yeah, maybe the printer tends to run a little bit on the wide side, but I think part of it is also that there's some variation, and the design decision, like, it's often going to change depending on like whether a little bit extra is fine, or you just don't want any extra, or you want to make sure to have enough. Let's see. It feels like it has more room, actually. It feels like it actually has plenty of room. Well, plenty for some definition. Yay. Okay. It's no vise, but that'll do. That's the bearing in the middle of the wheel. And then I think this needed a little more trimming still. Yeah, the screw heads especially are going to be tight, which is what US Water Rockets was saying, which, yeah, I should have added a little bit of clearance around the heads probably, but that was also one of those things where it's so small that I don't really mind doing it by hand after the print. She says, while being frustrated by doing the exact thing she says she doesn't mind. This is almost done. There's just a lot more bumpiness here than I was kind of expecting. Like from the, I assume this is all just from the belt on the printer. Maybe they need tensioning at this point. It's also a pretty subtle wobble. Like, I probably should have just not had the tolerances so tight. The perfectionist in me, like when I'm overthinking these things, like I would always just be concerned about you know, trying to overall have generous tolerances, but then to very specifically have certain places where I want to make sure that things have a specific fit, and then focus on those tolerances, which is probably a better approach. Like, definitely when I'm making like snap together enclosures, that's what I'm doing. But this, I was kind of on a different design track and wasn't thinking about that so much. More concerned about, you know, speeds and torques and stuff like that than millimeters of clearance this time around. And that's why this is an iterative process. And that is just kind of I think part of the problem here is, well, I don't know. Here are a few things that could be the problem. I think this might just be like the shape of this is kind of producing some especially bad fit given the particular artifacts the 3D printer is making. And the angle here is not really helping it fit better. I mean, the angle, the way I designed this angle was mostly so that once it was glued together, it would distribute the load pretty well, like in the middle of the spool. But Oh no, Ronald in chat. Oh, a couple of questions here. So Ryan asks, what grit sandpaper is good for the sanding I'm doing? I'm not sure what's the best. I have a couple of different, but I don't actually have a lot of different sandpapers here. Mostly I've been using these sanding sponges, which I don't have very many kinds of. These are actually fairly, I mean, these are like kind of medium grit. I'm probably terrible at estimating grit, but probably in the couple of hundreds. But I have some coarser sanding sponges that actually might be better for just removing a bunch of this material. I hadn't been using them for this so far because I don't have as many of them. And I've been using these because they're cheap and I have a bunch. But and for a lot of the stuff I sand, I worry about cross-contaminating materials. Like if I'm sanding something that's a particular color, I don't want to, like if I'm sanding something that has aesthetic value and it has a particular color, I don't want to get a different color in there. If I'm sanding something that, has, sometimes like with metals, like you don't want to have like aluminum in your tools when you don't want to be working with aluminum. So I don't know, I think mostly for me, it has to do with, I don't want to mix like metals and plastics, and I don't want to mix like different colors of plastics usually. But let me get a coarser grit sanding sponge. That might actually help. Oh, are they over here too? They're in the cart with the drill press. Yeah, so these are the coarser ones. These are, well, they're fine as far as 3M is concerned, but they're coarser than what I was using. And these aren't labeled with a grit either. And I don't know, I mean, I've been using the sponges mostly for these because I like being able to, they're really good for rounding corners and like smoothing out shapes and stuff like that. When you don't need stuff to remain planar. So I don't know, I'm not an expert sanding, but, oh, US Water Rocket says 320 grit is good for PLA, which I have not tried personally, but sounds about right. Oh, and then Ronald says, I love your work and your cam coverage, and even more that you like cats. Not like Dave Jones' EEV vlogs where he says he hates cats. That's weird. I haven't heard that. Like, I don't know, I have my own beefs with Dave, but I had not heard that he doesn't like cats, which, I don't know, I wouldn't necessarily hold that against somebody because, people can like whatever, but I certainly enjoy it when people like animals and like cats because it seems to be something I can get along with people over, and I don't know, like I certainly am a little bit suspicious of people that just don't ever seem to get along with animals because it makes me wonder, like, well, what is it about humans that they think is so different? Because there really isn't that much of a difference, and is it because they think they can, there's something they want from humans that they're trying to get? I don't know. I don't know, Dave actually has me blocked on Twitter. Like, I still watch his videos sometimes, but I don't think we could actually have a conversation. I tried engaging him a while ago when, I don't know, I sometimes think about doing like a rant video on this if I was in the habit of doing rant videos about other YouTubers, but I don't know if that's my thing. But yeah, he did this thing where, he does Mailbag and he says hi to people, but he had done this thing a couple of times where he just like makes just random out of nowhere assumptions about people's, about genders and like whether people care about his show. Like, so there's like the one thing he does where, I think every once in a while he does something related to his YouTube stats and talks about how, like 99.995% of my viewers are men, so I don't care about anybody else, and does that kind of thing, which is like not especially useful because those stats probably aren't accurate for a number of reasons, and even if they are, what use is it saying that? But I don't know, the thing that actually bothered me was he had somebody send him in some, I don't even remember what it was, but something from Mailbag, and it was, I think it was a note that implied that it was from a couple, and then he went out of his way to say like, oh, I wonder if she actually watches, or she probably just like puts up with it and doesn't actually care. And so it's like one of these things where, I don't know what the original intention was, whether whether, these were two people who were both fans, or whether it was just like, they were signing their name on this thing because they're a couple and they do everything together. Like, I don't know, there's a bunch of different explanations. But the way he treated that as something where it was just like an outlandishly weird thing to actually have a woman also interested in his show, like that bothered me. So I don't know, I asked him about it on Twitter and it didn't go anywhere good. He just pushed back on everything, didn't want to admit that, and it's like the kind of thing where, like, instead of actually engaging on the issue of well, okay, you've got some female fans out there that are maybe that you maybe have the opportunity to push in a positive or a negative direction. Do you care which direction you push them in? And I got a pretty firm no from him, and he seemed to be much more interested in kind of preserving whatever he had already made up his mind on than actually having a conversation. So I don't know. I don't remember exactly how that went down on Twitter, but he ended up blocking me, and we haven't talked about it since. So that was weird. At this rate, that 3D print's probably going to be done soon. This is just such a tight fit. I think on this side, it's like I'm not actually removing that much material. I'm just like polishing it. Make sure we have this fresh spot on the sponge. Sounds like it's screaming at me. Yeah, I'm definitely changing this design before printing more, because this is ridiculous. I think what I want to do is, because like I'm normally, like that strategy I was just talking about of designing things so that they normally have a good kind of wide berth around the interfacing parts, and then there's some pieces that are specifically designed to, compress a little bit and make a good fit. I like that, except this also happens to be like right smack in the middle of the load-bearing region of this. And maybe I'm overthinking it because ultimately this is a pretty light-duty object and it's not going to be holding up a lot of weight. But the way I was originally planning on having this work was this was a pretty tight fit, and then all of this force ends up getting transmitted pretty much directly through compression force of a couple layers of plastic into that bearing in the middle, which then sits on a metal bolt. So yeah, I think that general strategy is fine. This just needs some small adjustments to make a better fit, which could just be, I don't know. Then now I'm thinking about like, oh, how do I make this, back in Fusion 360 land, how do I adjust my design with minimal disruptance in that particular brand of optimization that is not necessarily useful in real life, but helps me learn the tool a little bit better. But then this design, like this particular print, is also supposed to answer some even larger questions, like, am I even using at all the right kind of motor, and is this at all the right diameter? So I think I'm going to have some more fundamental questions to deal with before I worry too much about the details of this fit. But especially when I'm dealing with like pretty heavyweight iterations where I have to like wait hours for a print or wait 10 minutes for something to synthesize on an FPGA. Like, at that point, I always want to have multiple things that I'm dealing with all at once. So like, while I'm waiting on my tools to tell me if I got the solution right to problem 4, I want to be like working on problem 6 or something and kind of pipeline it. This feels like it might be aggressive enough to actually do what I want. I just don't want to have to do this to every single thing. I mean, I'm only making 4 of these. It's not like I'm making a bunch, but it at least makes me want to optimize the design more. learn how to make the ultimate winch bot. I mean, I'm sure people will have different requirements for their winch bots. Shh, this is just not fitting. Yeah, it's actually really close though. Ah. Oh. Checking up on the chat. US Water Rockets is saying that the print is moving around and I should have used a brim. Let me take a look at that. Well, I don't know. This seems perfect to me. Yeah, look at that. It's exactly what we modeled in CAD. Well, maybe this is a good time to wrap up this stream. Since it's pretty late here, I'm getting tired / hungry / frustrated at all of this. And I think we've done a lot of useful work here. I think mostly I need to make some small changes to this, maybe even some small changes to the spool, but probably just some sanding and clamping on that. But yeah, turn on the brim on this, maybe make the hole clearances a little wider, and then try printing this again. It seems pretty solid though, like, if I can have this not be autofocusing all the time. This was a pretty high infill T-glass part, and it's, well, that was the weak point, but this part feels pretty sturdy. It's not going to be aluminum, but it should do what we want. All right. I think that's pretty much the stream for today. I'm trying to get you to some Tuco Cam to finish this up. Okay, credit goes to Sodium in chat who spotted the problem first. So yeah, thanks for that. I thought that it might have been doing that earlier, and then I looked at it, and no, but it's hard to tell with that camera angle because there's so much glare. You can actually kind of see how these pieces are supposed to go together. So on that side, that's how it looks once it's glued. That gap is not supposed to be there, but it'll be gone eventually after some more sanding. Then that's a slot for an M3 nut, and then that's the motor shaft. So, oh, and then this is the slot for the actual cord that I'm using, which could also stand to be a little larger. It's a little annoying to get the cord through here, and it doesn't necessarily fit if the end has been like heated up to keep it from fraying. But twisting it gets it through pretty easily, and then once it's through, it's actually fine. And like I could tie a knot in here. And that's not going anywhere. And then M6. I mean, I clearly haven't printed the other piece that this goes with yet, but that ends up going, there'll be a piece that kind of holds the nut right about there, and then motor drives it from the other side. Exactly like that. Just like that. Exactly. All right, I'll leave you with a few more seconds of the sleeping Tuco as I end this stream. Thanks for tuning in, everyone. Looking forward to making some more progress on this project and having a mobile cat cam. But as always, the journey is at least as fun as the final destination. So I'm enjoying making this thing too. And I hope some of you are enjoying being along for the ride too. And I certainly appreciate the help. This has been one of the more interactive streams lately, which has been nice. Happy hacking, everyone. Have a good night.